enjoy and participate in the Ieee Kenya SYP 2022. By SYP we mean Students and Young Professionals Congress. So today we are here at Panari Hotel, one of the best hotels in Nairobi.
This time, we'll gladly welcome you for all the sessions that will take place. Our special thanks to all our speakers, the keynote speakers, and also the invited talks. Indeed, it has been it's a privilege to have you here. We know that you had other activities that you were engaged in, but you spared some time to come for a conference. So welcome very much for our delegates from abroad. Feel much welcome and enjoy. We have fantastic events and activities, and also the beautiful scenery in Nairobi, Kenya, which I believe you will get a privilege to enjoy after the conference. Allies, thank you and welcome very much to our first conference. Thank you.
Good morning, everyone. Hamjambo. Warembo. Mko wapi? Hi, ladies.
Hi.
Hi, guys.
Hi.
Thank you very much. My name is Esther Moshiri, Chair, Ieee Kenya section. Extremely excited to have a full house. And not just a full house, but a house full of young, vibrant Kenyans and international delegates. Thank you so much for flying for so many miles across the seas to come and enjoy our beautiful country. Kenya is indeed beautiful, but what we also know is that we are going to draw a lot of wealth and knowledge from you. Thank you for all the sessions that you shall be sharing with us. And from me, as the first female chair of Ieee Kenya, I feel privileged and blessed that after COVID, this is actually happening. And every time I speak, I always want to give credit to my immediate past chair. I don't know whether he's here. Vincent, are you in the house? In absentia, I want to appreciate Vincent Egesa, because some of what we will be doing and we are doing in these 2 years of our term is really dreams that we built together, but COVID happened and we were not able to make them happen. But another special appreciation to my very young friend, Steve Okwiri, the chair of student branches at first at Technical University, but also representing the other student branches. You are a true leader, Steve. And I see a lot of brightness in your future, because you and Kithinji, representing the young professionals, you have led a fantastic group of young people who have put this together. Sometimes you see emails flying, and I have never seen my Ieee inbox so full. You wake up in the morning and you find 20 emails and you're like, where do these kids sleep? So please help me congratulate the organizing committee that has put this together. Hearty clap for them. I am honored that about a month ago, I attended the 119th Region 8 meeting in Cairo, where I met the fantastic gentlemen, professors, and honored that you have actually honored us with your presence. Being in their midst, I realized that Ieee is the place to be. My new friend from Kenneth, she just asked me, do you people get paid to be in Ieee? And I said, no, we are all volunteers. It is what you get out of it, this kind of networking, the knowledge. This is where you find people who are willing to give you what they have learned over the years. We are all, I would say, born mentors and born learners. And so for me, as we start this Congress, is to ask especially our young students and young professionals, please use opportunity to learn as much as you can. Make yourself an open book. Write as much. Do not see the professor sitting in that table and wonder, should I say hello? Should I ask? Be bold. This is your moment. These 2 days, be bold. Get out of your comfort zone. Speak to whoever you want. At first, it might feel awkward, and especially engineers are said to be very introverted people. This is time for you to get out of your introvertness and reach out to people, learn as much as you can. And at the end of the day, we are hoping that we shall all leave this place changed, converted, having made new friends, and aspiring to continue renewing our membership and aspiring to get to the position of my good friend Professor Ksyp, who is a life member of IEEE. That is where we should all aspire to be. I thank you, I welcome you to Kenya and to Jibambe. God bless you.
Okay, good morning everyone. I'm Maureen Musau. I'm from Kenya Education Network. In short, it's KENET. I don't know any of you as students who've heard of KENET. If you have, just by a show of hands. Yeah, that's good. So for me, I'm an alumni of JKUAT. I studied electronic and computer engineering. And I've been working for the last 13 years at KENET, so you can do the maths to see how old I am. We are very passionate about what we do at KENET, and now we are shifting more focus to you, the students. Mostly we've been working with educational institutions as an NREN, supporting education, research, and learning activities using technology. We'll be talking later about some of the projects that we are undertaking and that you can all get to benefit from. So one of the services I know you all know is internet connectivity to your campus. And I know for you to use that internet, you do require to have a laptop, yeah? So we've launched a program in partnership with Microsoft and Intel, where you students can be able to purchase a laptop. We have a booth out there that you can come and inquire from the team about how you can be able to own a device. So we'll be talking more about that, and also cybersecurity, which is a space that we are in for education. During that session, please feel free to ask as many questions and also engage the team from KENET. So I'm happy to see as many ladies as possible, and also the gentlemen. As she mentioned, just engage, network, and ask as many questions as possible. Thank you.
Well, good morning, everybody. I'll be a bit different from the others. You can see my age. I require some memory aids, and that's why I have some presentation. The other speakers have talked for 1 minute, so I'll steal those minutes which they had extra, so that I expound a little bit on what we do. I'm representing the government of Kenya, and I want to take you through what we are doing. I head the department called Research and Policy with the Minister of ICT. When I joined the government many years ago, I don't want to mention the years because I may scare the hell out of you, may start asking, and why are you still in the government? I joined there as a young systems analyst, and I was saying, why is the government so why are they not doing anything? I didn't know at one point, I'm in a position like here, now trying to explain what the government is doing. And now we are calling it Ministry of Information, Communications, and Digital Economy. Previously, it was known as Ministry of ICT, Innovation, and Youth Affairs. The Youth Affairs have been removed from us. Now we've been left with what we call digital economy. And what we have been doing is that we have been having a lot of initiatives in this space of ICT. I know engineers play a very big role, but she has been unable now to fix my system, so she has to go and get an expert. But I'll be reading from here. Now, one of the roles of the ministry is to facilitate the development of ICT sector. That includes broadcasting and multimedia, promotion of e-government, national ICT policy and innovation, the promotion of software development industry, provision of ICT technical support, and the policy on automation of government services, and development of national communication capacity and infrastructure, and the management of national fiber optic infrastructure. We are wondering, are we going to have our own Elon Musk out of this forum for their professionals program? Because actually that is where those are the people that we are trying to tap into. And you may ask, what has the government done to facilitate our own Elon Musk? In a few minutes I'll be showing you what we have been doing. So you may ask, what is it and why so much interest? I don't want to go to all these other definitions of digital economy. The core aspects, you know what they are. These are just computers and nothing more than that, the mobile phones. And we have come up with this evolution, generation of computers. We know where computers have been for a long time. I don't want to go to this historical thing. These are things possible when you had in a first computer class, when you're doing my first program. And now we're having the 5th generation. Fortunately, I will not be there in service. I may be doing other things. I will not be talking about quantum computing and nanotechnology. But these are the realities. At least I've been talking about AI. But these are things that we have in the market: the blockchain, IoT, cloud computing, 5G mobile broadband, robotics, AI, and so forth. And we're seeing a lot of new business models coming up. Uber, accommodation Airbnb, which is renting hotels like this. Online retailing like Amazon, that's actually where Jeff Bezos got his money from. Online learning, we saw from COVID that we don't actually have to we don't need lecture halls. People can still teach online, although students are just logging in, they go back to sleep. Then the lecturer is left talking to himself. Broadcasting is under a lot of threat because we get news before we even see them on TV, from Twitter, from wherever it is. Financial services, we know about M-Pesa, which you are told is a Kenyan invention, but you can not confirm that. Teleworking, our minister was supposed to open this thing virtually because he was very busy. And I think that is the way we are headed for. Email, well, email is an old technology now. But I would also say that we need to bring up the postal services. I don't know who has been to the post office in the last 2 years. Even me now, I want to go and find out where the post office is because I have a candidate who is doing exam and I have to send a success card. Yeah. So the question is, last time when I was giving a presentation somewhere, the one who was introducing me said that the next speaker is from the government, and these are the people who have been obstacles in development of technology. Well, also by the time I finish here, you tell me where the obstacle is. Fiber optic. We have rolled down 9,300 kilometers of fiber optic cable, but you're not seeing any traffic on it. People are not making use of it. You have fiber optic cable at every sub-county level. His Excellency the President said during Mashujaa Day, we want to roll out 100,000 kilometers. In fact, we were in a committee yesterday and trying to figure out these cables, where are we going to take them? Yeah? 100,000 kilometers is too much fiber. Hotspots. We want to set up 25,000 hotspots through the country. So you can go and see possibly your MCA and say you want a hotspot. Just right out here, outside your house. Yesterday we launched one at City Market. When I was a programmer some time back, and I was trying to do some online applications, I used to go to somewhere where there is Wi-Fi, and then I sit at the car park there, and then I use the data there. Now it has been brought to your doorstep. Last mile connectivity, you're connected to 200,000 schools, and we are continuing to do that. One-stop shop, all kind of services, you can get them online. And that's actually, we say that we're going to digitize 90% of all government services by the year 2025. National payment systems, we are trying to come up with easier ways of settlements. You don't actually have to carry cash. So I don't know what the thieves are going to do. They cost you. You tell them now I can only do it using my biometrics. E-citizens, you know about that platform. Digital literacy program, smart city data centers, national record system. This is an enabler for e-commerce. We want to physically map each and every homestead, so that when you are telling somebody where you come from, you don't say you have to jump a river. There's a tree you find there. That is my home. You count the homes. We want to physically, when you give your address, somebody can deliver a night and light to your doorstep. That is one of the initiatives that you are working on that. PKI, I think you know about it. CIRTs, I don't want to go into that. 5G rollout, you're working on that. Innovation hubs. Every constituency in the country, they have what we call a constituency innovation hub. I don't know how many of you have used it. And you have equipped them, they have internet connectivity. We went up and did a survey and found that most people are there doing betting, watching other funny films, instead of being innovative. Yeah? Smart cities and so forth. We also have what we call the President Digital Talent Program. We have the Agenda Training Program, and many others. So when you blame the government that we're not doing enough, you need to come and then we discuss and tell me what else do you want us to do. So we don't expect you to just be saying Serikali's idea. If you think there's an obstacle somewhere, come to me or come to the ministry and say, here, I want to be facilitated. We are there for you. Now we also have come up with a regulatory framework. We didn't have rules to deal with cyber crimes and so forth. This was enacted in 2018, Computer Misuse and the Cyber Crimes Act. We also have Data Protection Act, so that your data does not get lost, misused. You also have access to information. Now you have right to come and say that you want information from me. And I'm legally obliged to give it to you. It's in the Access to Information Act. We also have a number of ICT policies, the National ICT Policy 2020, National Broadband Strategy, where you seek to give everybody connectivity, digital economy blueprint, and the digital master plan. The focus area of the National ICT Policy is on mobile first. We want everybody to have mobile phone, smartphones for that matter. So we want to make them inexpensive. We want to increase the market for digital integration community by 10%. Skills and innovation. We are giving you skills. We need to find them. That's why you're looking at these people, these richest people, and we want to find out what skills do they have. Unfortunately, when you're itemizing their skills, they were not very, very positive. Bill Gates was a dropout in a university. Larry Page, who owns Oracle, I think he's a high school guy, and so is Jeff Bezos. Larry Page did not finish his master's in engineering at Stanford. So the question is, what is actually missing? What is the missing link? Yeah, Mark Zuckerberg, the guy behind Meta. We cannot even call him in a forum like this because he will be embarrassed. Yeah. So we are trying to work closely with the educationists and find out what is actually missing, so that now we can put it in our curriculum, public service delivery, and so forth. I don't want to talk so much about digital economy. There's a blueprint where we talk about digital government, digital business, infrastructure, innovation-driven infrastructure, skills and values. And the major challenges that we're facing is on security threats. I think all of you are aware. Responsible AI, digital divide. The people in the village, are they able to use smartphones? By the way, they are able to use smartphones. My watchman has an iPhone, better than mine. I don't have an iPhone, by the way. And also development of homegrown solutions. Yeah, we're looking at you to come up with solutions. Now, IT security goals, you know about those ones. I don't want to go with those ones. And what we have come up with is a body we are calling NC4, National Cyber Security Coordination Committee. It's about agency force, bringing people from ICT, Ministry of Interior, the police, prosecution, KDF, so that we try and address these cyber threats. Because if I was to give you the statistics of how much you're losing daily from cyber criminals, we may be shocked. It's only that there's a policy, we don't go on broadcasting what you have lost. So what we do is that we just keep quiet, and then we try and find out what are these young people doing. Yeah. As government, we will continue putting up ICT infrastructure. In fact, right now we have excess capacity. Someone talked about the laptop projects. I think every university students can get a laptop, and we want to make it even more affordable. We're trying to give even to standard ones, then that project somehow we're not going to it, but we are still visiting it. We're going to improve access to ICT, especially broadband. We're also going to ensure efficient public service delivery. So that when you go to offices, don't just look at a civil servant and think that this is actually going to be a nightmare. You can apply for a passport at the comfort of your home. You can get your driving license, you can renew it, you can do whatever you want. Right now we're trying to deal with the biggest menace, the traffic policemen. So we are going to put cameras. You know, they were saying they're going to give them uniforms with cameras and with no pockets. But now, what you're going to do, we're going to put on cameras at many major streets. Now we identify your vehicle. For example, if you commit a traffic offense, immediately we send a message to you by M-Pesa that there was this offense. Then you pay the fine by any electronic means. You don't have to go to court. Yeah. So that we want to maximize convenience. And we also maintaining a record of what you did. So you will not be finding many policemen on the road. When I was coming, they had so many of them. They kept stopping me because I was driving a small vehicle, which after this I'm going to change and go to my farm. So they kept on stopping me and look around and say, go ahead. So we are aware of that. And we're looking for you people to give us technical solutions. Not me. Me, I'm just like a spokesman. You come and tell me there's this innovation solution and it can be used. Then I escalated. We validated to have what we call incubation hubs. And then we see of what value. We can even assist you to commercialize it. That is actually one of the things that we are doing. Put the private sector first, enhance capacity, and leverage on ICT to promote sustainable development. Well, I was not supposed to say all this, but I was feeling that if I sit down and I say I come from government, people will be saying that one of the biggest enemies was here, and he never said anything. So the question was, is the government the culprit? Is it the obstacle? Or is it the people who have given everybody whatever they require, and they are not being innovative enough? So possibly by the end of the conference, you'll be looking at how can we be more innovative, so that in the next conference, you'll be showcasing the various products which have come up from the very innovative engineers we have in the country. We always look at what is actually happening in the social media, Twitter, Facebook, and so forth. There's a department which is scanning. In fact, we have software, AI. And recently there was somebody who was saying he's an engineer, an electrical engineer, with a first class honors and a straight A person. And he was saying he doesn't have a job. He has to go to Jenko construction site. And then we had a meeting. We do meet and discuss. And then you're wondering, now how can we help? We have given everything. So possibly you're also going to address, I don't know whether that student is here. He's an electrical engineer from one of the universities. Did anybody see that? or you don't follow social media. We do. And possibly those are some of the things that we don't want such a situation. I want next year, God willing, or whoever will be coming here, we'll be saying we're impressed by the technology that is coming from Kenya. We'll be saying that Kenyan engineers are the best in the world. We want our own Elon Musk. You see, he came from 2017 from Norway. He was not among the ones who was sitting down there. He just came, and within 2 years, he is the richest person in the world. In fact, I think he bought Twitter. I don't know what else he's going to buy. Possibly he can even come and buy the country. We say, well, how much is Kenya? I want to buy it. And you're worried about that. So with those very many remarks, sorry for taking much of your time. I know tea is out there. I don't know what is next. Thank you so much. Thank you.
Good morning. My name is Dr. Mary Ahuna. So I will put that title because I have my seniors in the house, professors from Kenya and also around the world. I take this opportunity to welcome you all. And to our very wonderful speakers, we do not want to limit you too much, but in the interest of time, let's manage at least 10 minutes per person, at most, sorry. Yeah, thank you very much. I'm standing here on behalf of Technical University of Kenya as one of the collaborators and partners in this Congress. For more details on the Technical University of Kenya, you can always check that on the website. And just to mention, it was chartered in January 2013 by the then President, Mwai Kibaki. And more information is on the website. And I'll just say on behalf of the Vice Chancellor, he's aware we are here, Professor Engineer Francis Aduol, and also on behalf of the Executive Dean, Faculty of Engineering and the Built Environment, Professor Edwin Ataro. And on my own behalf, I would like to take this opportunity to welcome you all in this prestigious first IEEE Congress of its own kind that has brought together students, young professionals, and faculty members from around the world just to come and share ideas and also see how we can advance and move forward as a continent, and also a country, a continent, and also the world at large. So I'll just take this opportunity to welcome you all. Feel at home and let's network as much as possible so that we can be able to get all that we can get from this conference. For the organizers, we say thank you very much. Our young students, young professionals, you've really taken your time, as one of the speakers said, that even at 1, 2, 3 a.m. you still see information flying over, and we say thank you very much for taking your time for this. So for that, I say Karibu Kenya, Karibu Panari, Karibu to the Congress. Welcome.
Our speaker spoke for a couple of minutes. Thank you very much. It's okay. So I just want to highlight something you said at the end, which really is very important. We were in Rwanda the other day, courtesy of IEEE Kenya and IEEE Power and Energy Society. I'm the chair of Power and Energy Society, so if you hear me talking a lot about it, I'm a bit biased, to be honest. So looking at the police sector in Rwanda, you feel like you're in a whole different world. You're not even in Africa. Looking at the police sector in Kenya, I think we have one of the, I know you're from the government. I'm very happy to see you're from the government and you're seeing this as a problem that actually needs solution. Kenyans are very brilliant, as you can see. Kenyans are very brilliant, they're very smart, and they're very hardworking. And one of the things that has really set us back is our police task force and the route that goes into that. I was in a cab with a driver this morning, and I have this discussion with every other cab driver, just because it's something that I really feel, if our police force is set in order, then everyone will be in order, right? If you're, let's take it back to class. If your prefect doesn't do the right thing, if he doesn't get you to know there are certain rules that need to be followed, and you can easily, you remember in class when you used to be written for noisemaker or something, and you can easily pull your yourself out of that? Would you ever behave? Would you ever know that you need to do one or two things? So I'm very happy to see that the government is looking into that. Please put those cameras. It's usually so embarrassing. You pass and you just see those hands being put money on the side. We are a society that can do very great things. We have many Elon Musks in here. If you know you can be the next Elon Musk, please clap for yourself. So if you can really sort that out, I really felt we need to emphasize that. And the government has said we'll get cheaper laptops. you'll have access to digital literacy. So let's take opportunity of that. We say this platform we are brought to, make sure you get connected to the right people. These are people you wouldn't be able to walk into their office anytime, but we have them here today. So please take this opportunity and make sure you network and get these networks in to really serve you. So thank you very much. Without further ado, we'll be welcoming our next speakers. Please, a round of applause for them. Paul, I hope I'm pronouncing the name right. Henrich Lu, we were discussing, is it Henrik, is it Henrich? So we have Henrich Lu, one of the youngest professors. He became a professor at 28 years old. So you can find out later how old he is now. And he's also graduated with distinction with bachelor's degrees from from South Africa. And on top of that, he's also done research and is published in the Ieee Antennas, SPS Society. He's also going to speak to us today in a topic called From New to Old, how to transition from academic environment to the real world of engineering environment, which can teach you valuable lessons about the broader aspects of engineering profession. So just before a bit of background again, in 2019, he returned to his home now in Namibia, where he's worked with the Bayer Water Corporation Limited as an engineer, and now he comes from the Ieee Namibia Society, and on top of that, he's the Society's Young Professional Ambassador for the year of 2022. Thank you, Dr. Lu. Karibu. Professor, sorry.
Thank you very much. It's a privilege to be here. It's just doctor, not professor yet, but thank you. I aspire to that. I got my PhD at the age of 28. So let's see. Thank you so much for having me. And today we're going to talk about the transition from academia to industry. So once when I was doing my undergraduate degree in electronic engineering in South Africa, I met a middle-aged electrical engineer. And he heard that I was studying electronic engineering. And he said, "Oh, so you'll become a project manager." So I was a little bit offended by this, that he would make this assumption. At another time, I was doing holiday work at my bursary company back home in Namibia, and I asked an engineer whether he actually used any of the mathematics that he learned at university. So he thought a little bit and he said, "Yes, but sometimes things you wouldn't even expect, like number conversions." And I thought to myself, are you serious? Number conversions? Am I spending 4 years at university to learn how to convert meters to kilometers? And so the sad reality is that many young people enroll for a degree in engineering because of their passion for design and for solving complex problems. But when you get to the industry, then sometimes you might be disappointed when the real world engineering work doesn't always entail that in-depth design that you were trained for at university. And I suspect that this is a particularly big challenge in developing countries such as Namibia and South Africa, where I spent time studying and working. And there you do find some companies doing really high-tech design work, and especially in the research and development companies in the defense industries, for example, but they are still relatively few and far between. And so unfortunately, I suspect that even perhaps the majority of electrical engineering graduates in Southern Africa do not end up doing the kind of in-depth design that they were trained for. And I do suspect that this may be the case in some other countries as well. So where I'm from, if you do get an engineering job, you may end up working as a project manager in procurement, sometimes in maintenance and repair. Some end up basically becoming operators. Others are effectively employed as bureaucrats. And if you're lucky like me, you might get to do some basic design combined with some practical installation and maintenance. And so when you choose engineering because of your passion for design and for discovering new things and solving complex problems, then This reality can be a little bit discouraging, but I want to encourage you today. I mean, when I started working, I have to be honest and say that I was not initially too excited about the work that I was going to be doing at my bursary company, Namibia Water Corporation. When I joined them in 2019 after completing my PhD. Today I'm employed in the communications subdivision, where we mainly do telemetry, which is the remote monitoring of water infrastructure across the country. So it's more of a practical engineering environment. It's not a research and development environment. So over time, over the past few years, I've had a big change in my attitude towards my work. And I went from just trying to do my time, as it were, to really developing an appreciation for the practical engineering skills that I was learning. Before, as I said, I'd only thought about engineering in terms of design and discovery. But through my time in industry, I realized that engineering is actually so much broader than just design. I was always looking for complex problems to solve, but I eventually realized that in a practical engineering environment, the issues that are complex are not always just design issues. So in this talk, I'd like to share some of the lessons that I've learned in industry and look at the broader scope of the engineering profession. In particular, I'd like to help you see how adopting the right mindset from the start helps you to get the maximum benefit from your time in a real-world engineering environment. And so the main thesis of my talk today is that simple things become complex in a real-world environment. Simple things become complex in a real-world environment. I'd like to take you through a few different experiences that I've had in industry so far, and firstly, highlight a few key lessons that I learned, and secondly, also some key differences between academia and industry that you'll need to be aware of. The first example from my experience is a proof of concept versus a real-world pilot project. So as part of my PhD, I designed a new type of antenna array system. So even in my PhD, I didn't only do a theoretical design, but I manufactured a prototype, which you could see here on the left. And this is a so-called compressive antenna array. So I did gain some practical experience, but it was still very different from the experience that I gained in industry. When I started looking at NamWater, my first task was to design a new server backup system for our SCADA service, which you can see there on the right. Now, these servers we use to monitor the water supply infrastructure across the country. So they are crucial to the water supply operations, and they also log data, which is important for long-term planning. And due to poor power quality and reliability in many areas of Namibia, a reliable server power backup system was required. So the idea was quite simple: connect off-the-shelf chargers and inverters to off-the-shelf batteries. And so compared to the PhD that I just completed, I thought, this is a very simple assignment. However, the requirement of reliability made this problem significantly more complex to solve. To start off with, I proposed a redundant system made of two independent backup systems. So that means that the service would not go down if any single component failed. But that also meant that if a single component failed, you wouldn't know about it unless you monitored that. So everything had to be monitored in detail. And in total, I ended up monitoring 113 different variables, including 19 different voltages, 12 currents, 8 powers, 7 temperatures, 16 states, and 45 different alarms, just to make sure that nothing was going wrong with the system. And so even though I was only connecting off-the-shelf devices together, integrating devices from different brands for this level of monitoring did pose some significant challenges. I also realized that to make the design sustainable, I had to make sure that if any one particular component became unavailable, that it would not require a major design change, as this could be very costly in future. And this is particularly important when you take into account that the design service life of a system like this is more than 10 years. And so I had to choose components today that would still be available, or at least for which there would be alternatives in 10 years' time, which again made the design more complex than I initially thought. You can see therefore that in industry, the challenges move from having more to do with the fundamental technology to having more to do with the implementation. And this brings us to our first lesson, which is that a simple design becomes complex when designing for real-world implementation. And the first key difference here between academia and industry is that prototypes are technologically complex, but real-world designs are complex in implementation. The second example from my experience in industry is about collaboration across domains. At the end of my first year in industry, I had the privilege of being responsible for the telemetry component of a containerized reverse osmosis water treatment plant. Now, this plant was installed by an external contractor, and my responsibility was to connect it to our system and to create a human-machine interface so that you could monitor the plant remotely. So here you see that HMI, or human-machine interface page, and this is what gives you a graphical overview of the plant and shows all of the key measurements. Now at that stage, I knew nothing about process engineering or osmosis or even water treatment technology. And so I had to learn how the reverse osmosis process works, at least so that I could draw this page accurately. And so even though for a chemical or process engineer, the working of a reverse osmosis plant might be straightforward, it was complex and it was interesting for me simply because it was not in my domain. It was in a field that I knew nothing about. And so this taught me our second lesson, that a simple concept becomes complex when it's in a foreign domain. And by this I simply mean that something might not be right at the forefront of technological innovation, but it can still be complex and interesting for you if it's not in your domain. And so if you find yourself in a work environment where you're not particularly stimulated by your own field, then I challenge you to look further and be curious about other domains. When you're working on a project with somebody from a different discipline, I mean, even if you speak to your HR officer or somebody from accounting, then ask questions and use the opportunity to learn something new and to make life interesting. Industry often provides unique opportunities for collaboration across domains. And this brings us to our second key difference between academia and industry. That research is more specialist, but industry is more generalist. Now, of course, there are opportunities to collaborate in academia as well, and you can apply these same principles there, but in general, industry teaches you a broader range of skills which can be extremely beneficial further down your career path. The third example from my experience is about assessing alternatives in the light of real-world requirements. So at each of our radio frequency or RF outstations, we have a radio connected via coaxial cable to an antenna with some RF components in between. So try to visualize that. In order to do maintenance and fault finding on these RF systems, we used to use what's called a watt meter, which is an RF power meter. And so you place this instrument somewhere along that line, and then you can measure the power being traveling forwards and the power being reflected backwards, and you can see if there might be an issue with the system. And so my task was to replace these old watt meters that were almost all broken. Now these watt meters, interestingly, they appear to be rugged, but we found that when we take them out of the field, they actually easily got damaged. And so for this reason, I decided to only consider alternatives rated to mil-spec, PRF 28800F class 2. Now that's environmental specification, and that's a measurable way of confirming that a device is suitable for use in a rugged environment in terms of vibration, shock, and temperature, for example. I also decided to go for a more advanced cable and antenna analyzer, which is a more advanced test instrument. And so this lets you do what's called a line sweep from the ground, which you can use then to pinpoint exactly at which distance there is an issue along the RF system from a single measurement from the ground. So you can have a tower, we have one that's about 275 meters high. So you could stand at the bottom and you do this line sweep and it measures across the whole line and it can tell you exactly at which point there's a fault on the system. So for this I needed two components. A power sensor firstly to measure the power from the radio, and then also this cable and antenna analyzer with this line sweep, or what we call a distance to fault functionality. Now when I looked at alternatives, I saw that many of the cable and antenna analyzers have an internal power sensor but with limited accuracy. And up to that point when we went to site, we specified that for our maintenance visits, the power from the radio should be correct to within plus minus 10% or 0.4 dB. So that was the specification, within about plus minus 0.4 dB. But the built-in power sensors in these analyzers were typically only accurate to plus minus 1 dB. So I looked at more accurate external power sensors that could be used with a cable and antenna analyzer, but they were quite expensive. And the one that I did find that was rated to the environmental specification did not cover the required frequency range. So basically I couldn't find a product that met the specifications. And there was no solution that met the conflicting requirements of the high accuracy as well as the ruggedness, and so I had to compromise on one of these two specifications or requirements. And so I had to take a step back and ask whether this specification for the power accuracy really addressed the need. So what was the need? The need was not actually to accurately measure RF power in the field as if you were in a lab. It's only simply to confirm that the radio in the field is still within a good working condition. And so for this need, an accuracy of plus minus 1 dB is actually more than sufficient. And so I opted to choose a rugged cable and antenna analyzer with a basic built-in power sensor, since this met the true need. So this brings us to our third lesson, which is that a simple choice becomes complex in light of conflicting real-world requirements. Again, purchasing a new test instrument at first seemed like a very simple task. But the real-world requirement for a rugged test instrument made the whole task significantly more complex, and it actually took me a really long time to reach the chosen solution. And so when you study engineering, you might think that at its core, engineering is about making complex calculations because of all the mathematics you do in undergrad. But in actual fact, the process of assessing alternatives and making decisions informed by engineering principles, whether they are design decisions or other types of decisions, that's what's really at the heart of engineering problem solving. And so in order to assess alternatives properly, an incredibly important skill is to identify the real need that informs the requirements and the specifications. And this is much more important in industry than in academia. Because in academia there's more freedom to explore research topics because they are simply interesting or new. And often in research you may even discover a solution before you know what problem it solves. And this is often how technology progresses. So the third difference between academia and industry is that research is solution first, but industry is problem first. That is, research focuses on developing new solutions primarily because they are new and interesting, whereas in industry you're focusing on solving real-world problems, and you are unfortunately wasting time and money if you're not addressing the real need. So there might be many things that you find that are interesting to you that you might want to explore, but if they don't address the real need, then in industry generally you should focus on what the real need is. Now, of course, this is somewhat oversimplified, but this just gives you an idea of the difference in focus between academia and industry. My last example from my experience in industry is about making judgments under real-world conditions. So within my time at Manwater, I designed a UHF radio link. You can see the antenna there, where the telemetry station was about 47 kilometers from the repeater. So I finished my design, and then much later when I went for installation, a colleague of mine questioned whether that antenna would actually be high enough, because he said that the stations in that particular area often struggle with communications. So I found this surprising because my calculations didn't show that, but I delayed the installation in order to get more clarity on this issue. I sent somebody to site to go do some practical field tests, but although the results were worse than I had calculated, they were borderline and therefore still inconclusive. And I had to decide what to do since the project was being delayed. And unfortunately, I could not simply use a longer pole because the container that you see there would not be able to support a longer pole. And so in the face of incomplete knowledge, I decided to continue according to the original plan despite the uncertainty and install the antenna as per the original design. And my justification here was that the potential benefit of it working outweighed the cost of having to take it down if it didn't work, and that it was worth trying considering the additional costs and delays of having to investigate an alternative solution at this late stage in the project. So I installed the antenna as originally planned, and although the performance was worse than expected, it was actually still acceptable. But after this, I had to try and figure out why there were such huge discrepancies between the calculated and the field results. And I really had to delve deeply into the assumptions behind the calculations to find the source of the discrepancies. And so this example shows the importance of understanding the assumptions behind theoretical models and also the quality of your input data, and not just blindly using an algorithm. In this case, it was a software package that we were using. And so I'd like to highlight 3 lessons from these experiences. Lesson 4 is that a simple calculation becomes complex when ideal assumptions don't hold. Sometimes it's only in the real world that you discover assumptions that don't hold, and you might never have known about these issues if you only work with theoretical models. And the corresponding key difference is that theoretical models are based on assumptions, but real-world phenomena do not always obey assumptions. Now, of course, you can and you should investigate real-world conditions in academic research, but often those in industry are in the best position to identify real-world challenges. And that's also why collaboration between academia and industry is so important. The 5th lesson is that a simple judgment becomes complex in the face of incomplete knowledge. So the key difference here between academia and industry is that unanswered questions in research are future work, whereas real-world decisions in industry need to be made despite unanswered questions. And so this is one of the key reasons why industry experience is so valuable. Judgment is only really developed when you are forced to make a decision despite not having all the required information. So in academia, you will often rephrase a problem if you don't have all the answers, or you can even leave some questions unanswered for future work. But in industry, decisions need to be made, whether you have all the information or not, and this is how you develop sound engineering judgment. And so lesson 6 is that a simple decision becomes complex when the consequences are real. And with this, I don't just mean making the decision itself, but rather executing that decision and taking responsibility for it. And the key difference here is that poor judgment in academia has indirect consequences, whereas poor judgment in industry has direct consequences. Now, this doesn't mean that poor judgment in academia doesn't have consequences. It can have devastating effects, but it's more indirect. And it's incredible how difficult it can be to follow through on a decision in industry where the consequences are real. And this has personally been one of my biggest struggles in industry. I hate uncertainty. And when I have to make a decision where I feel like I don't have all the information I need, it can be paralyzing. It's like there's a mountain in front of you, especially if mistakes are expensive in terms of time and money. And making that decision and accepting the consequences takes real courage. Now, unfortunately, I can't tell you how to learn this courage, apart from realizing that you can only learn it through experience. And I think this is by far not only the most challenging aspect of industry, but also the biggest advantage of being in industry, that you get to practice those decision-making muscles, and you learn the courage to follow through on decisions that have significant consequences. So in conclusion, let's just summarize our lessons once more. A simple design becomes complex when designing for real-world implementation. A simple concept becomes complex when it's in a foreign or unknown domain. A simple choice becomes complex in light of conflicting real-world requirements. A simple calculation becomes complex when ideal assumptions don't hold. A simple judgment becomes complex in the face of incomplete knowledge. And a simple decision becomes complex when the consequences are real. I hope that these lessons will help you to maximize the benefit that you get from your time in industry. Thank you.
Thank you very much. Another round of applause, please. Now at least you know if you want to go into research or if you want to go into industry, who to talk to, right? And how to go about it. So thank you very much, Dr. Henrich. So we're going to have breakfast, mid-breakfast rather. And as we do this, in the interest of time, we're requesting that you could pick your tea, come back, and we continue to have the cup of tea. So karibuni chai.
again, you love to learn Karibu. So Karibuni, back to as we continue our session. And in the interest of time, I'll welcome our next speaker. So I'll welcome Olivia Karibu. Olivia is the head of innovation studio from Visa in Sub-Saharan Africa. Karibu, Olivia.
Thank you, Charlton. Just checking if you can hear me. Thank you, thank you. Thank you all. So I have 10 minutes and I'll be very brief. My name is Olivia Etiang. As Chatu has introduced me, I am the head of an innovation studio that Visa set up in Kenya for Sub-Saharan Africa. Obviously, Visa has been in existence in Kenya for over 15 years, but we are part of the global group. For those who don't know Visa, Visa is a global digital payment technology company. We serve financial institutions, governments, merchants, fintechs, startups, and just power up payments in that space. I'm here because I was introduced by Steve Okwiri. Steve is my mentee. So Steve asked me to come and give a talk on digital transformation and its economic impact. So thank you, Steve and the team. And it's really an honor for me to be here. So I'll get straight into it. As I said, I have been in the industry for over 18 years. I previously worked with M-Pesa, and we have been pioneering payments in this industry. And so when we talk about digital transformation and what technologies we are looking at that are really shaping up industry, we would start from home, right? Charity begins at home. So we'll talk about mobile money. So these transformative technologies like mobile money. So we've seen mobile money that has existed for 15 years in Kenya. Kenya is really just setting the pace for the world in terms of mobile wallets. And we've seen a lot of fintechs mushrooming out of this, mobile money and the space that has been created. Yeah? And what does that mean? There's a whole generation that has grown up not knowing any other way of handling cash or dealing with cash. And I think I'm speaking to some of them in this room. Yeah? They only know how to M-Pesa me, yeah? Because that really met a customer need, right? So we see mobile have penetrated so much in our lifestyles, in our economy. We have seen penetration of mobile money. And I was just looking at statistics, just to put this into perspective. M-Pesa agents handled 12 trillion in the last year. This is like 31% of Kenya's GDP, right? Yeah, so this is quite significant. I mean, what we are doing with mobile wallets. And if you get to see the ease of use of mobile wallets from, the guys who are using on a feature phone, the ease of payments of your bill, the ease of movement of funds from your bank to M-Pesa, M-Pesa to bank, and all that. So that was a real disruption in the banking industry, yeah? And really that represents, transformative technology. Mobile money represents that kind of transformative technology. But we also seeing its penetration, by the way, in places like Philippines. We've seen its penetration with Grab in Indonesia. We've really seen how mobile money has transformed the way people do things, the way people sell, the way people buy, and all that. And so leading us to the second transformative technology that I'll talk about is what we are actually seeing with the mobile internet. Yeah? So with mobile internet, we are seeing how selling retail through digital commerce. I'm sure today you have been able to see someone's perhaps WhatsApp status, and what do you see on those status today? Someone is selling some goods or service. It's become as if you don't need a shop to sell, right? You no longer need a physical store to sell. And actually this was fueled by the pandemic. After the pandemic, it became guys became so digital savvy, guys began to buy stuff, digitally. We have seen, a lot of online selling, yeah? So we had Mark, the CEO and chairman of Facebook, laying off staff, 11,000 staff yesterday in the news, yeah? And he says that when the pandemic hit, they expected that digital payments, would grow, accelerate, and remain at that pace. And we are also, what he noted that was of interest to me is that we're actually seeing this digital commerce, guys going back to face-to-face commerce. And so they're not able to sustain the guys that they had employed to cater for the growth, right? Because there's been the growth has slowed down. So despite the fact that there is that, because that's also an economic impact, right? Guys getting laid off, we are also seeing a lot of stickiness on guys using digital technology to do commerce, yeah? To purchase things online. I mean, and that's why the likes of online marketplaces are thriving. Amazon, Jumia, we're just having Black Friday coming up, so you'll hear a lot of those, yeah? So we power up those kind of payments, and that is digital transformation, yeah? We're also seeing a lot of consumer behavior changing. Consumers wanting to, use the most seamless and easiest way to do anything, to interact with a seller, right? And so that is through digital technology, right? I also want to say the third one would be cloud computing. When I was just starting out at Safaricom as a technician, we had not so many startups as we have today, yeah? And during that time, there weren't so many, it was very difficult to break through into this industry because you needed infrastructure. So infrastructure was a real challenge, yeah? But imagine what cloud computing has come to do. Today, anyone with, your small startup, you can size up and get what really fits you with cloud computing. Cloud computing has enabled organizations to drive performance with a lot of ease and be very competitive without thinking about the cost of infrastructure. It becomes very easy even for organizations then to connect to, IoT and artificial intelligence technologies on cloud as opposed to on-premise infrastructure. So we're seeing a lot of, simplified ways of doing things. For example, disaster recovery. Yeah, becomes very easy. Switch over time now. I used to do those things. Switch over time now would be like, just a matter of seconds on cloud computing. Before, you'd have maybe one data center in one place. Someone else has to go to the other data center. As you switch off, then you switch on. It's a process that takes even like an hour or more. And in that hour, you've lost customers or you're giving customers a bad experience and all that. So those are some of the benefits that we see with this new technology of cloud computing. Then big data. Big data is big. Big data is big because today we see it driving competitiveness. We see it doing a lot of predictive analysis in the industry. For example, the insurance company is using a lot of data on how I've seen them use, and they install this telematics device in your car, and then they can build up your consumer driving behavior. And based on that behavior, they can give you a cheaper policy, right? For your premiums, because you're a good driver, right? And if you're a bad driver, then you would pay that at an expensive price. So it's also improved, using that device, for example, you can be able to optimize transport routes for the commercial vehicles and even just improve maintenance. But we are seeing big data drive everything. Recently, Safaricom was speaking about how big data is the one that is driving the way they're able to establish the amount of Fuliza that you get. Yeah? So amongst other behaviors, your calling behavior and everything, they have an algorithm that is able to establish that, this is how you have been, paying up your loans, or this is how you have been depositing money. And so using data, yeah, that they collect from everywhere. So big data is really a good technology and a driver in what we see, and we even see its economic impact because then you don't waste time in, some of these things become very automated, right? Like you can just go to your phone and you're able to see your limit, right? Your whatever limit that you have. But it also gives us good experiences. Imagine that because of big data and AI, I am interacting with a merchant, Ksyp. Ksyp says that every 1 week I go to buy my groceries. This 1 week that I miss, they're able to tell me, hi Olivia, what happened? Can we send a rider? You know, that kind of experience is what we are trying to build. So that is by using big data and even artificial intelligence to be able to sell. Yeah? I'll also talk about blockchain, but before I talk about blockchain, I'll also talk about IoT. So I've Internet of Things as another technology that we are seeing that is quite transformative. We have seen, like I spoke about telematics, but we've also seen, you know, this kind of technology being put on your metering systems. Yeah? So now metering systems already have some sensors, and you're able to interact with them without just having a human person. So this saves cost for, you know, utility companies like KPLC, you know, Nairobi Water and all that, if they install smart meters. By the way, this has taken off in countries like South Africa. They have big projects around smart metering. I think we have smart meters in Kenya, but maybe not to the scale that we are seeing in other countries. Yeah? So IoT, and that powers up IoT. We see Coca-Cola, for example, using IoT to be able to fill up the fridges for the retailers. The fridge is able to tell that I've run out, and so an order is made. So we see how IoT is also making a lot of impact in the supply chain systems. So second to last is blockchain. So blockchain has really had, you know, like a huge momentum in the marketplace, especially in relation to crypto. So I know that crypto has to undergo regulation, but we see, in fact, Kenya is one of the top 10 countries in the world that is, you know, interacting with this kind of technology. Blockchain has especially changed how we do international money transfer. Yeah. So like I said, a lot of you may not be familiar with, you know, organizations like Western Union, because they existed then and they were very popular then because they powered up, you know, money transfer because of the wide agency network and all that. Yeah? But what we are seeing right now is that blockchain, and you know, with that kind of, you know, the money transfer, you're expecting money from US, perhaps it may not come instantaneously, you have to go to an agent to withdraw that cash, but now blockchain is really disrupting the international money transfer space today. And we are seeing the likes of Binance, we are seeing the likes of, you know, of course there's Bitcoin, but there's a lot of crypto around it. But also just solutions that have been built to utilize the current, you know, currency, but the settlement technology, behind it, powering it up, is actually, you know, enabling for faster movement of funds from, you know, banks and all that kind of stuff. So we've seen Ripple and all those kind of companies trying to use blockchain to improve what we do around money transfer. Money transfer is especially close to me because for about 3 or 4 years at Safaricom, I led the team that was handling remittances. And today, and that's why we still say mobile wallets are transformative, is that, would you believe it, M-Pesa does like almost 75% plus of all remittances that come into this country. Yeah? Because when someone sends you money from the US, yeah, they want a confirmation that you've received that money immediately, right? So that experience is much better than you sending money to your bank account, you don't know whether you got it, and all that kind of stuff. So a lot of Kenyans and Kenyans have really loved to adopt technology, so have adopted this technology. And we see how, continuously look to see how to improve, you know, this kind of consumer experiences, payment experiences using technology such as blockchain. Yeah? But we can also see blockchain in real estate with smart contracts and all that kind of stuff, again with the supply chain industry, giving a very significant contribution to what is happening in the industry. And lastly, I know I've taken, hope 10 minutes. So metaverse, yeah? The last digital, technology that I think is very disruptive is metaverse. Because, and as you might have heard again, Meta invested almost a third of, its income to metaverse, right? And why is metaverse why do we think that metaverse is this digital technology of the future? You see, you are going to be able to do things from the comfort of your home. So imagine that you want to purchase a dress. You want to be in a shop. All you need to do is get into a virtual reality environment, pick the dress that you want to purchase, and use virtual reality to actually fit the dress and then order for it. I think for us ladies, we're already used to virtual reality with lipstick, yeah? But there's gonna be, being able to purchase stuff, just, get into virtual reality and do stuff like that, yeah? So it's really already transforming the way we do things, by the way. If you're a gamer and if you like to game, you know that if you get into those virtual realities, you can even buy NFTs, You can buy NFTs. 3 minutes, thank you. So you can buy NFTs. NFTs are non-fungible tokens, yeah? We have seen people buy real estate in virtual reality, the likes of Snoopy Dog. They're buying real estate. So youngsters like you, I don't see you going to buy shares. I see the behavior of consumers changing really. At some point you will be buying NFTs. That will be your investment. Yeah? So these are technologies that are coming up. I'm so privileged and honored to be with a group of engineers such as yourself, just to, stimulate your thought around what you're doing in your space and what these emerging trends are to us. So I wish you the best for the rest of the sessions. Thank you very much for having me.
Thank you very much for that innovative presentation. We proudly, as Kenya, stand behind M-Pesa, especially if you go elsewhere and you see the real convenience of M-Pesa. So thank you very much for that presentation. We will be moving on to our next session, which is a panel discussion on technology challenges and market demands. This session is going to be led by our very able Kithinji Muriungi. He's the chair for Young Professionals in Kenya. He's also the vice chair of Ieee Kenya section. And this session we're going to have, and as I call out, you could start coming out to the stage. So we have Professor Marek Jasin, even on email this name was hard, Jasinski. He's the head of Industrial Electronics Division at Waswa University of Technology, and he's also the chair of Ieee IES SYP Activities Committee. Next, we have Vincent Tegasa, who is the immediate past chair of Ieee Kenya section. He's also another mentor in the Kenyan society, Ieee Society. We have Dr. Mary Ahuna, whom we have put in for Professor Amer Zarieg to support the session. We also have Richard Moura, who is Assistant Director of Research and Policy at the Ministry of ICT. So welcome back. We have Kennedy Kiprotich, who is the Senior ICT Office at the State Department for ICT and Digital Economy. So welcome and take us away. Hand of applause for them, please.
Again, karibu, Prof. I'll keep on saying this to our international audience. Karibu means welcome. So we'll have this discussion, and Chaltu had to remind me thrice that Kithinji, you have 30 minutes and stick to it. And if it all goes well and maybe the discussion is heated, it's fine. We can extend a bit. But I like having an interactive session whenever I have a mic, and that is the kind of experience that I hope this panel here will give us. I'll be very quick into their responses, and at some point even cutting them short so that we get to hear their perspective in different stuff. That is one. And then number two, we'll have a couple of series of thoughts around the topic. And then later, we'll have audience. So one mic on this side and then one mic on this side. So we'll get 3 questions, one on this pillar, the other one on this pillar, and the other one on the other pillar. So that is the way I look this happening. And I hope now this being expert around this area, or rather not expert, but leads into thoughts of how we are supposed to look into this topic, I hope it will be very interactive. And just to start, I'd like to I hope the mic is on the other side. Just to have an intro from each one of us. And apart from the intro, tell us your general view of the topic. How do you understand the topic? Our topic is building a resilience future. And then the second part is technology challenge and market demands. So your brief intro and how you understand about it. I had allocated 2 minutes, but because of time, please make it less than 1 minute. Yeah, we'll start with you. If it's not working, you can pass the other mic.
Okay, I think it's afternoon.
Yeah, it's already in the afternoon, yeah.
So good afternoon, delegates and members of KYSP. I'm Kiproti Kennedy from the State Department for ICT and Digital Economy. I'm a major in computer science and a graduate from Chuka University. I think what I understand about the topic is that we need to build or to align our skills for the young graduates to fit into the needs of the labor market in the near future. And also as the government, we are putting in all the efforts and putting in place the necessary infrastructure to enable the change and to handle the market demands. Thank you.
Thank you, Karibu. And I think when the government speaks, you don't cut them short, eh? Yeah, I had to keep quiet so that at least you can go on, but let's make it brief as possible. Straight to the point, yeah.
The government had talked, so I don't need to introduce myself, so I want to say that minute. You know my name and I articulate what we do. Suppose we go to the next speaker.
Yeah.
Prof. Amr Zarek from Libya, leader of this chapter, and I came here for attending my own Libyan University, and really I am very glad to be here between you. And these talks, it was very interesting and very nice talks, and I agree with advanced technology and carrying things and so on. Thank you very much.
Yes, my name is Vincent Egesa. I'm the immediate past chair of the Kenya section. I also currently sit on the Africa Council as the secretary. Professionally, I'm in ICTs, and my viewpoint on this topic really comes from my experience in advertising, media, and working in an FMCG. So, thank you.
First of all, thank you very much for your invitation. I'm very glad to be here. My name is Marek Jasiński. I'm from Poland, from Europe. This is more or less eastern part of Europe, close to Ukraine, Russia, and so on. This is, probably the situation there. Not the best. However, I see that people everywhere are the same. And I'm really glad to be here to listen to how the energy introduce the technology to our, let's say, life. My field is power electronics, and surprisingly, in power electronics, we are using more and more IT technology without the algorithms, without control, without sophisticated and intelligent smart grid, for example. Probably we could not manage the energy as information. Thank you very much.
Yes, thank you, Prof. Marek. And I think the audience, you can see the kind of panel that we have. We have an international kind of view. We have government side, we have industry, and we have academia. And that is the kind of neutral views that we are looking into having. And another thing that Vincent mentioned FMCG. So these are fast moving goods. So Vincent doesn't deal with metalworks, he deals with things which move fast, like consumer something that we can eat, things like those. Now, the second question, I like to take a general approach here. When I look at the topic, especially the first part, it has three main keywords. It has the resilience, there is part of building, and I think Richard actually brought it out clearly, what building means and what the government has been doing. But also, more importantly, there is the future part. So as a representative in a specific area that you are representing, we have an international from Poland, we have a person from the industry, academia, and the government. I want you to build a case around this in a minute or less, responding to this. What actually do you understand by this, and what does your area contribute to this? So that we look now to the next part of the question. So I will start with Prof. Marek. So what do you understand by building resilience and specifically future? They don't have the questions, and that makes it good for us to get a real response from them.
Oh my God, thank you very much for this subject, first of all, because everybody thinking how to, let's say, make our life better in the future. And we are not the first in this subject, I would say. To be honest, I was thinking exactly about this subject when the pandemic was started. And we were afraid, everybody probably. And I found in the internet that United Nations has 17 points to grow our society as human beings at the world, yes? This doesn't matter that I have different color of skin or something like that. I'm teaching international student at Warsaw University of Technology since 2008. Also students from Kenya sometimes came, and I found that people are the same. It doesn't matter where are they from. Something like in, I would say, Star Trek. So, what I'm understanding about the resilience. So, these 70 steps really are important. You can follow them. There is from poverty, zero hunger, up to the scientific skills and success in your field of interest. The second point, because 17 points are quite long, even though I would like to read them, this is not enough time. So I'm thinking, what is the basic of, let's say, our existence? What is IEEE, for example? Of course, this is for letters, yes, but in IEEE, I came because of my mentor, Professor Marian Kazimierkowski. He is also from Poland. He asked me, Marek, you should join the conference just to meet the people from your subject, from similar interest, and interact with them. And I think IEEE is, for me, myself, is the interaction with people. Really, I appreciate that I can meet you, that I can discuss you, and I can learn your point, and maybe we can make some synergy effect after this. So other things, everybody here focused on IT technology. I was really impressed your presentation about the mobile apps. I learned before I came here, so now I know who is doing this. Thank you very much. So, but IT will not survive without power supply.
Prof. Marek, thank you. I wanted to say 5 seconds. Yeah. So, yeah. So the next speaker, please make it even shorter than a minute. But what I'm getting is SDGs is actually big on that, because for us to build and maintain resilience, and more above that, focus on future, what I'm getting, the key underlining word is SDGs. Thank you. Next, Vincent.
Okay, so I would just like to use a brief analogy. You know, when you talk of building resilience and future, think about it like, if you've ever had to build a house, you need to consider the foundations of this house, because you don't want the house crumbling immediately there's a big gust of wind or a bit of an earth tremor. So you need the foundations to be good enough to hold the house. Second, you want it to be resilient. You want to be able to use that house for a long time. And perhaps future proof, so that in the future you can add on to it without having to bring everything down and start building a new house. So when I look at that, the one thing that I think is going to be critical, and it's a very difficult topic, is perhaps regulation and control. And not regulation from the point of choking advancement of technology, but regulation to make sure that the technology and its applications in industry and society is safe and can actually be reused. So any technology can be reused in one part of the world, in another part of the world safely without endangering the users.
Thank you, Vincent. Next, Prof. What I'm getting is policies and regulations, because those points will actually reuse them. Thank you. Yes, Prof.
I think the technology is running very fast and we have to follow it, even IT or smart grid. And this thing is running very fast, we have to follow it.
So for Prof is we need to be digitally aware and actually get into speed. So speed is key. Yes. Okay, perfect, Prof. Thank you.
Yes, again, you have mentioned everything. When you talk about the last, it's always a problem. But the 17 SDGs, Sustainable Development Goals, just acclimatize yourself to them. I was supposed to go to Cairo to talk about climate change and ICTs. I didn't know much about climate change. And fortunately, Kenya went on strike, so I was very happy because I didn't have anything to say. But as a government, our main aim is to maximize convenience to Wajiko. If you don't know Wajiko, you see me after this. And also, we want to reduce operational costs, which will lead to less taxes and also more revenue for the government and even more revenue for the government. And also, we want to create employment for you people. So, there's quite a number of things to be done, but I don't want to take a lot of time, so we'll discuss more about it later.
Thank you, thank you. So what I'm getting from, so Prof, in Kenya we call them serikali. Yes, serikali, the government. So what I'm getting from Richard is convenience and cost, which is very, very important. And I'll pass it now to Kennedy.
Thank you. I think when you talk about resilience under this ICT sector, now we need to understand that technology is changing rapidly. And resilience, it means we need to build a rapport for the future generation. And now, this future generation, they are the people who are currently in school now. So, to have them capable of handling the future changes, we need to equip them with skills at their tender age. And this is where now the digital literacy program by the government is coming in. So as a government, I think we are very ready and prepared to handle this resilience with the long-term SDGs.
Yeah, so another serikali speaks, and what I'm getting is actually focus on the younger generation. And I will build that into what Vincent said about focusing on the foundation. Now, the second question that we are looking into is the second part of our theme, which is technology challenges and market demands. Now, based on what you talked about, what are these technological challenges that are kind of hindering us to build resilience for future? And as you talk about that also, tie that into the market demands based on what you mentioned. I'll be reminding us. So I'd like to start with you. Your point was equipping future generations, especially DLPs, and making sure that they are kind of well prepared to handle, to build resilient for future. Now, looking into that, what are some of the technological challenges and market demands that we're seeing? And maybe I can poke this question this way. We've seen these laptops going around, but we barely hear them going mainstream. We've seen a lot happening, but of course they are kind of tied to one school or rather one region. but not really the whole constituency. So as you talk about this, what are some of these technological challenges that government is facing now that you've brought that point from the government side of things? And what are these market demands?
Thank you. I think approaching this from government side, we need to be privy to the fact that the resources are limited. So that's why you can't implement this DLP project across every part of the country. So you're moving step by step. And I think now because we're involving students and young professionals, a challenge that is coming up is there's a huge gap between our curriculum and the market demand. The labor market, if you look at the labor market and what we teach in school, there's a big variation in that. So we need to address it and resolve it for us to be able to handle these changes.
Perfect. Thank you very much. And maybe just to bring to attention to our international guest is that Kenya has launched the coding curriculum, if I'm getting it right. And yes, and we are hoping as we focus on building foundations and equipping our next generation, I think the government is doing, let's give credit where it deserves. At least they are trying. Sawa sawa. Yes, and thank you very much for that. I've gotten a couple of points here. At some point, privatize things. Number two, step by step. Remember, we are talking about future resiliency, and we are building this together. So some of these things, we will see them while we are in the age of Professor Kuzu, actually materializing at that point, and then we will actually look back and say, step by step has actually paid off. And then building the gaps and bridging those gaps. Thank you. So your point was convenience and cost and tax. And I will maybe like to bring this. What are some of these technological challenges and market demands? And I'd like you to talk about now the taxes that we've seen brought in the last few days, where people are kind of now told to increase, and then there are some other mechanisms. So if you can maybe bring that into light, it can actually be of value, especially conveniency and cost. Thank you. 45 seconds.
Is it on me now?
Yes, it's on you.
Yes, you see, everybody wants lower taxes, but you want more services. The government cannot operate without taxes. So we have to find ways of getting more taxes. But we have to widen the tax bracket. The government is also looking for what we call stability, both social and economic stability. And some of these technologies are bringing a lot of disruptive changes. Somebody just mentioned that Facebook yesterday sacked 11,000 people. I don't know what would happen if somebody says now we are sacking all civil servants with immediate effect. I don't know even, I'll just collapse here. That's what I'm seeing in service. Then also having things like security challenges. We have been having meetings about drones. People are saying the market requires drones, but then us in the security forces and airports authority, civil aviation, we're wondering, if you allow these drones, are they not going to be a threat to airspace? What if they fall to the terrorists? Because they say there's a drone which can be programmed so that it will just come there and target me and hit me, so you just see me expire. So those are some of the challenges that we're facing, and we have to support for them. Thank you.
Thank you very much. And as you mentioned about drones, and I think that is one of the topics that so many guys here are very, very much comfortable talking about. But I like the way you are putting it. I had a talk a couple of months in Konza, and I talked about the peculiar things that has made Silicon Valley grow to the point that it is. And one of them is actually tax kind of stuff. That is a discussion to another day. But I like you to think about that lines and maybe challenge the panel to actually expound it further. Why is Silicon Valley able to do it? And when I say Silicon Valley, I mean Jeff Bezos. Why is he able to do it? What kind of things have happened? Which kind of lawyers are they working with him? What kind of government are they? Why are they allowing that to happen? But again, we'll narrow down to some discussions around that later. Now to our prof. Prof said that, Prof. Amer said that we need to speed up This technology is not waiting for us. And I was just having a talk with someone so that I build a case on what Prof is saying. And one of my close family was working on a final year project. She's a psychologist. And then she wanted to build a case around artificial intelligence. When she went to the professor of psychology and told her, Prof, I want to work around this area utilizing artificial intelligence, the professor told her, this technology ni ya kizungu. This technology is for those ones who are there. It's for the West. It's not yet here. And if I'm getting Prof right, is that this technology is here with us and we need to run with speed with this. So Prof, which are the challenges that we are seeing, and is there a demand for this? Is there a demand for this?
Yeah, because as I mentioned to you, the technology is running very fast. But from point of view, really, we have to encouraging the young generation, because really some people, when they touch or reach the degree of the Prof, he ignore the people under him. Supposed to be encouraging the students and the young generation and show them the technology, because even any Prof, this is the life. The life and what we're going to say, the years are running, and maybe when they going to be die, suppose he leave a point to they remember him, because the young generation, this is the most important people in the future time.
Thank you. So I think Prof has actually realized that we expire soon. And if you are to expire soon, we have to do it very fast, so that before you expire, you've already done your part. To Vincent was about foundational and specifically regulations and policies. And maybe I'd like you to revisit what Serkal said. Richard said, how do we balance between letting the innovations of drone in the hands of civilians without compromising the military standards? And I'd like you to talk in a policy. I know I've put you in a very hot seat, but I'd like you to handle it in that manner. How do we balance? How do we strike the balance between regulation policies, using the case of Richard?
Yes, so when you look at technology with that reference, it's inevitable. Technology is going to change. It's going to change very rapidly. And if you put in policies that will sort of restrict adoption of technology because you want to control, what you will find is that you're no longer in touch with what's happening elsewhere in the world. So I would say what we need to look at is perhaps some level of agile policy making, meaning policy should be able to keep up with the rapid change of technology. To highlight it a bit, there's a group of researchers who've been able to push equivalent of the entire internet continent down, I think, a 50-kilometer line per second. Just think of what that means. So if your policy is to try and manage flow of information, then you're in trouble. You will not be able to. You always find that you're playing a backstep game. You cannot manage that kind of data transmission. By the time you're even trying to intercede in the current conventional means, your entire knowledge pool or data is gone to another part of the world. If you're looking at it from the point of view, for example, employment, that means if you become too restrictive, if your policies are not encouraging innovation and growth, I can quickly move my entire workforce to a different country or a different part of the world in a matter of seconds. I'll have all the data I need. All I need to do is to pick up the people who will continue with the job.
Thank you very much, Vincent. And I think that is what Rwanda is doing, right? That is what Rwanda is doing. Investors come here, they have had time getting in, and then they went to Rwanda. Now we have a drone ecosystem there, which is doing very well. That was just an example, but we have so many other examples. Now to Prof. Marek, you talked about SDGs. If you ask me, it's one thing to build a case in business world, it's another thing to build a case in a scientific world. Now, how do you balance this so that you are actually building for sustainability and not just building for the sake of building? Yes.
very good point. We are engineers, so we have to cooperate very close with industry. In my case, I'm trying to make some scientific project in common in trying to introduce the product into the market. But I would like to, let's say, call to your main question. What is the main challenge? In my opinion, is energy management. There is two sense of this energy: technical sense and human being sense. Yes. So the energy for the society is young people, definitely, always. So in this sense, we have to focus on the quality of education and standard of education. From the technology sense point of view, affordable and clean energy. Yes, I don't know how it's in your country now, but in Europe it's a huge disaster according to the energy crisis. The prices is going up 300% more than 1 year ago. So my question is, are we able to control the energy in such a way like we are control information? Yes, this is the open question to myself, to everyone here, because in my opinion this is the crucial point from the market and market demands. Without an energy source, we cannot do any information technology, we cannot even survive. Yes.
Thank you very much, Prof. Marek. So I'll just ask the last question so that we can pass mic back. And the last question is, of course, what is well known to all of us, especially where we prime ourselves as the Kenyan kind of ecosystem. And I like to put it this way. We have, now that Richard kept on mentioning Konza for like in 3 slides, he kept on repeating Konza, 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 Konza. I've been in Konza project for 13 months, so I know exactly, not 13, 14, close to 15 months. So I know exactly what Konza means, and I know the potential Konza it has. And on top of that, I know some of us here have visited some of places which mirrors Konza. South Korea, Korea, some have visited Singapore, and importantly, some have visited even Silicon Valley, where we borrow the name Silicon Savannah. Now, just a quick question. I will want your response in 30 seconds. What they did right, what we are doing wrong, and what we need to do for us to build Silicon Savannah. Because if we are able to build Silicon Savannah, then we are able to build a resilient future, and we will solve technological and market demands, because we will bring all those things that we keep getting out there here. And we'll start here with Prof. Marek.
Okay, thank you very much. Excellent question. Silicon Savannah, well, you have a potential, definitely. To manage this, we need, I think, peace, justice, and strong institutions that are supporting us with our hard work. This is not a secret. Who is an engineer in this room? Raise your hand, please. Any engineers? No engineers, Joseph? So, you know, to obtain the goal in engineering, you have to spend a lot of time, a lot of efforts, a lot of crying in the lab. So this costs a time, and we can take a look into the past, how the science was progressed, but I don't have the time for
Thank you, thank you, thank you. Next, let me break something here that he has said. He has mentioned something that I'm very sure it has passed most of us, or so I assume. He has mentioned the term lab. And the few of us who have been in a public university, we know the condition of our labs. But what he's talking about, I will want us to reference to the short key lab, the lab that built Silicon Valley. Think about that critically, and then we'll have that discussion later. Vincent, 30 seconds.
Yes, so I think we need to take up what maybe I would call the thought leadership, especially at the topic I was talking about, regulation, governance, etc. We need to come up with the standards. We need to come up with the best practice and the good practice in order to make sure that we are leading those engagements and discussions. We should not necessarily just be waiting for somebody else to set this up and we are following. If you want to build a Silicon Savannah here, you need to be able to lead the way and lead those discussions. So we also need to make sure whatever environment we are giving our thought leaders allows them to think, allows them to grow. I don't want to go into detail, but you remember what happened with the ICT regulation agenda that happened a bit? You know, it had challenges, and the industry reacted, the users reacted, the communities reacted. So we need to make sure whatever we are doing from the standards, best practice and good practice is something that is engaged with the stakeholders and something that can actually work for us to grow out there.
Thank you, thank you. What I'm getting is this thing cannot be built by the whole mindset. If you have stuck to the system that believes things run this way, you are not the right person to build this. It needs a different mindset. That is what I'm getting. And more importantly, it needs standards and some more stuff to that. Prof, yes, what did they do wrong? What did they do right? What are we doing wrong? And what can we do right?
Yeah. I think they do right. We have to concentrate for the students, for undergrad or postgrad. Concentrated on the project, not only for the things, reading and doing exams and on. Supposed to be concentrated for the experimental part and confirmed by using simulation tools.
Thank you. To the lecturers in the room, this is a challenge. To the students in the room, this is a challenge. Don't just do exams for the sake of exams. These communities will not be built by papers. They will be built by brains. What you will come out with university is what you will print. That is what I'm getting from you, Prof. Thank you very much. Richard.
Yes, I will not go into what we did wrong, because it may be of obvious reasons.
Thank you.
But you know, we are given a facility, which is a public facility, where you can showcase the innovation. We have an incubation hub. You bring your ideas, we give you the test environment, we have the sandbox, and you can try out whatever you want. One of the biggest challenges we're having is coming on technology is something we're calling e-waste, and possibly you engineers can help us on how we're going to manage it. Like we are getting a lot of equipment which are becoming obsolete very, very quickly, and we don't know how to dispose them. So about e-waste management, if you have ideas on how it can be managed effectively, you're in job tomorrow. Thank you.
Thank you very much. That's like a job offer. Yes, just present yourself and all will be done well. Yes, Richard. Sorry, Kennedy.
Thank you. I don't think you have done anything wrong yet. Maybe that, only because that we started at late, it doesn't mean you have done it wrong. Them, they went ahead of us. But we are steadily moving towards that direction. And but maybe what we need to encourage more is the brand Build Kenya, Buy Kenya,
Build Kenya.
Build Kenya. And by doing so, we will move far much ahead. Maybe we'll catch up with them.
Thank you very much. And I hope you are seeing the response from the two gentlemen from the other side. Serikali, you don't critique the government. Yes, thank you very much. And we are really happy at least to have a discussion with these very prominent people. They have shared the insight with us. A round of applause to them. So, yes, so Chaltu, please allow us to have one question, the burning question, instead of three, and then we will close it at that. One question. Who has the, yes, the first hand always gets it. Yes, from that guy. Quick, please. You can stand. SYP, energy ko wapi? Where is the energy? Yeah.
So, good afternoon, everyone. So my name is Ksyp from the University of Nairobi. So my question is, it was basically a thought. So with the increasing, let's say, technological advancements we have, the world is becoming smaller and smaller. But as we have seen recently, with the disputes across the world, the technology and the innovations we have is always beholden to the states we have. Case in point, when the US banned China from using some of their proprietary software and technology. So my question to the panel is, as we move future, as engineers, as we come with innovations, how can we build a resilient future so that our innovations and our technology can transcend any diplomatic issues and can be used everywhere without being interrupted by the states or the countries we are from?
Thank you. We'll just get one more question from the guy there. His hand was also up, and then we will answer that.
Good morning, good evening, everyone. My name is
Good night to you too.
So my question is a simple one. In the past years, we have noticed that foreign companies are coming to invest in Kenya more and more and more. For example, we have Amazon and Microsoft setting up offshore accounts in Kenya. Yeah? So my question is, how does this affect the future of innovation in Kenya, considering that now these companies are coming and hijacking talent from existing Kenyan companies?
I like the way you are thinking. I like your thinking. Thank you very much. So let's get speakers responding to that. Quick mic, maybe we can have this. We can just pass it around and...
Richard, I think is the right guy to answer first. Yeah.
Well, you're saying, I just talked about economic disruption. No country would wish another firm would come and disrupt it. That's why America, Cisco is fighting Huawei, and because they say it's going to affect their industries. And so if they find there's someone who has a competitive edge, they have to put a brake so that at least their people come out to the same possibly competing scenario. Same case can happen here in Kenya. We don't want somebody who will just come and disrupt us. We have seen Uber, and possibly those of you who have traveled by Uber, these people are always complaining. They are saying these taxis, we don't even know where those guys are. They're just sitting at the beach waiting for us to work for them. And it's a very bad scenario. Now, when we talk about other companies hijacking talent, we need them. And we need you now to come and compete with them. So they are raising the bar for you. We don't want to stop Google. We don't want to stop Amazon. We don't want to stop Microsoft. But what possibly you can do is that if you have an innovative idea, just bring it on the table. And then we say we can come up with policies. If we have a tangible alternative and tell Google, can you ship out? In Europe, they are trying to stop Google, and also Australia, saying that now Google, you are too much. But sometimes, since they have more resources than even the Kenya government itself, it will be very difficult to tell Google, go away. Because they can say, okay, fine, you want us to go away? And then you see now bringing them a lot of political upheavals. Thank you.
So when I look at the issue the Americans were having with Huawei, if you look at it, I think it's an issue of who got to the market first. Huawei is already rolling out enterprise level 5G technologies to telcos. Very few of the traditional telco companies were ready to challenge them, and that was the problem. So by putting these stumbling blocks, you try and hold it back, but you really can't hold that for long. If you think about it, the biggest growing economies now are Africa. Huawei is big in Africa, so they are still maybe not getting the American and European companies, but they're all over the African companies. So they are still growing, they're still improving their technology. So I think the important lesson there is get to the market first. You will get speed bumps, but by the time the speed bumps come, you already made a good inroad into it. Then with regards to Microsoft or other technologies coming in, it's inevitable. It's inevitable. And I think the same principle applies. You have a good technology, get to market to it fast, get as much as you can out of it. Chances are Microsoft will be approaching you to say, look, we would like your technology. How much are you willing to? That is how Elon built his fortune. You know, he sold PayPal, he sold a few other companies. Meaning, come up with the idea, put it to market, get revenue out of it, use it to build the next idea. I think that's the story.
Thank you. The last one from Marek, Prof. Just a thought.
Yes, thank you very much. Really excellent questions. Two questions. In my opinion, the main problem is with high technology, new technology. Why? Do you remember when the personal computer has been introduced into the market? One scientist gave an official statement. What for personal computer? Why do we need personal computer? Please raise your hand who don't have computer at home. So can you imagine that 4 or 50 years ago, one scientist told that maybe computer could be good for 1,000 person, one computer just enough for 1,000 person. This is scientific statement. However, now means like science fiction, isn't it? So focus please on new technology that nobody understands. We don't know the potential. The potential of new technology and high technology is in our mind. So this is very, I can understand politicians why they are afraid, because high technology is very costly and the profit is quite long in back. Quite long. Some examples. Do you know Copernicus? Copernicus found out and proved that the world was round and circled the sun. Yes? He was from Poland. Okay, by the way. Next one. Do you know Marie Curie Skłodowska? Marie Curie Skłodowska also, she was Polish. However, you know, she was stopped learning because in that time in Poland, it was forbidden for ladies to attend universities. She has to go to Paris, and in Sorbonne she studied, thanks to French people. My God, without her, we couldn't survive now. Yes? And other last example, Czochralski, probably nobody knows this guy. Czochralski also was Polish. He found out how to grow up semiconductors. Do you know what for we are using semiconductors? Everywhere. In every computer, every mobile phone. So in that time, it was in Berlin. Accidentally, he was making in the lab research, and he was so tired after many, many years engineer working. He was so tired that he made a mistake. He was drinking a tea, and instead of tea, he was putting his spoon into the semiconductor and grow it up. Oh, it works. And after that, we have iPhones.
Thank you very much. So I don't know, I love to have a pause at that, but maybe just to sum it up, what I'm getting is there's someone who mentioned about Huawei and Google. I'll tell you for sure, there is no technological battle. It's a political battle. And for some of us who know what politics does, that is the fight can go. Number two is about standards, IEEE, Wi-Fi. You can use it anywhere you go. So apart from us building things from our kind of frameworks that it will be very hard to be adopted, we can think of standardizing things, and then we became the first one to own those standards, and then it can be mainstream. Number three is about the question about Microsoft and all that. So when Stanford realized that all their students were going on the West, to get employment there, one of the professors challenged them and told them, instead of going there, think of building things here, and then the companies can grow here. It was a dream, but right now, what those professors planted, it's now powering the entire world. That is my punchline to you all. So I'd like to, I don't know, Chaldu, I'll pass it to Chaldu. If she will allow our speakers, they can do their punchlines without me involved, and then we can call it a day. Chaldu, 30 seconds punchline, please. Don't even.
3 words, yes? the family is the key for the success of our society, in technology and in everywhere. Thank you.
Wow.
I think I'll just have to say, take the lead, write the narrative. Don't wait for it to be written for you, and you'll be in control.
I think you don't sit and don't do anything, just carrying the technology.
We want innovation for our problems, not just certificates. Thank you.
And for the students and young professionals, I would want to say, own your space and ensure you always strive to excel. Thank you.
Thank you very much.
Round of applause as they leave the stage.
I will welcome our next speaker, Professor Ksyp. I'll allow him to introduce himself and to introduce the topic as well as we continue to learn today. A hand of applause. All the way from Australia.
Feel free to stand up, all right, stretch your legs, or if you're going to think while I'm trying to sit, it's up to you guys.
Yes, actually while he sets up, there's a team I forgot to mention earlier, a very brilliant team from Multimedia University. Louder! You saved the best for the last. And I was told also I did not introduce myself with the punchline I needed to introduce myself with. So due to public demand, I'm Chantu Martha. I usually say I wear many capes and people ask me, how do you make the many capes? I'm like, I merge them into one very beautiful cap. I make them marry. So I'm the secretary for Kenya section, serving under the guidance of our very able chair, Esther Muriuki. Sorry, Washira. Mushiri. I'm a bit nervous. If you can't tell. Introducing myself is where I get nervous at. So I'm Chantu Martha. I'm also the secretary, I said I'm the secretary of Kenya section. I'm the chair of Power and Energy Society. And a shout out again to them as the silver sponsors. The others will give a shout out. And I'm also an electrical engineering background. I serve as a solar engineer at WGITS and Energy Solutions. We do phenomenal projects. Actually, one of the projects that I led the company to do was in the tea sector. And it was the first big project this company did. So apart from winning awards from myself, we've also won awards for the company where we are doing, I love social impact. So it's not about awards. By the way, none of the awards I've applied for, oh, you're ready. I was keeping these people busy. So I'll continue the introduction later. You can come for an in-person or we can continue the conversation later. Karibu.
Lovely, thank you very much. Yeah. All right, good afternoon, everyone. I hope you all are not saturated with information after this wonderful panel discussion. My name is Yusuf Ibrahim. I'm from Australia, from Victoria, somewhere near Melbourne. I've been asked to talk to you about the topic. My field of research is mechatronics, mobile robot navigations, and also industry automation. So I left mobile robot automation back home, and I would like to talk to you today about something that we have experienced in Australia. It's a case study about how university can help industry to help government objective, because the government objective is the economy and employability of people there and competitive edge of industry. So, however, usually university has different agenda from government agenda. So how can we sort this out? I'll let you know. Okay, this is Australia, as you can see, and this is, I mean, you can put all Europe around Australia and something will be left over. I'm not going to talk about it anymore. How many of you have been in Australia? Anyone been visit Australia at all? Yeah? 1, 2, 3. Well, this is invitation for you guys to discover what you are missing, right? Okay, and so where is the center of universe? This is Victoria, all right? The state in the south of the continent, and then this is where I live, and that is the center of universe for me. Okay, about 150 kilometers east of Melbourne. Okay, we try to, my field is industrial automation and mechatronics. And then I found mechatronics somehow degree that I established was taken away from me somewhere else. So I had to use my understanding of technology to the benefit of the community I'm living with. So what we have done, I found that I developed something called GRACE, like Amazing Grace, but it stands for Gippsland Regional Automation Center. Why? Because in the region we live there, you have fishery, we have also beef industry, we have beef industry, and the milk industry, and power generation industry. So we can cooperate with them to help them to meet their own objective and help our community to improve the sustainable edge in the market. So I tried to build a model for the center, and I believe it was really good model. As I said, government coming from one side and industry coming from one side, and both of them coming with different agenda. Industry want to improve competitiveness, improve the throughput, and improve, government want to improve employability, want to employ more people, and for the government, that's the government. University has different idea about research. University want to publish papers, university want to employ PhD, university want to get research grants, and sometimes it doesn't mind if they have just a PhD sitting on the shelf without anything. Excuse me, my voice. So what we have done is we managed to have a technology development prototype, IP, that's a university, and then we came with commercialization partner, and that is from industry, and also from there we have the product industrialization, right, and system integration. These people, these are the arm of industry. Well, I'm fine. And then you have market development. In the market development, you have the people who support. The problem is when you improve something or you create something new, you want to develop this. We are in university, we are not business people, we are scientists. So we need people to help us in thinking very quick. We want to improve this sort of marketability. So that was an arm for us. And then, in addition to that, we have the Gippsland Regional Automation Center that encompasses both the technology development, that is the university, and the industry. So what I got $500,000 from 2 industrial establishments in addition to the university, and that was matched by another $500,000 from the government. So government in Australia works only on if you have leverage, they give you fund. If you get money from industry, they give you fund. So that's why the whole center budget was up to for $1 million. So, and then you have the customer integration, and the customer integration that goes through both Gippsland Regional Automation Center, through the industrial arm, and also the technology development arm. So that was, I'm not going to spend here. You have here the part suppliers goes through this industrial arm, and then you have the structure of GRACE itself. So, okay, the structure of GRACE, it could have been incorporated entity. However, the government wanted to be incorporated entity away from the university. But the BCE research said to me, okay, we're going to have a building here attached to university. What will be in it for us as a university, giving your time, giving $500,000 for lab space, etc., etc. So what I've done, got it as semi-incorporated entity. Incorporated just means it has a board of governor, all right, and it has university representative, and it has industrial arm in it, and I am, as a director, had to report to them every 3 months about the achievement, about what we have done. Quickly, we have commercialization manager, we have R&D unit based, and we have, that's for IP management and prototype development, and we have technical advisory committee that meet with us to tell us about what sort of topic we can work on. All right, I'm not going to go through it because I have limited time here. All right, I'm not going to talk about the IP management. IP management, of course, we have to go through it on the vision of the technical advisory committee. We have collaborative working together with relationship with lead customer, and the risk of adopting advanced new technologies in it, and also formation of partnership agreement with the industrial partner about the IP, intellectual property, and focus on customization of system to suit the specific need, and depict everything in modules so it can suit different needs of customer. So, all right, automation, the first job of us was automation of fresh fish sorting. So how would you automate? We have a company there that produce thousands of tons of school whiting fish, and they export it every year to Japan. Before exporting to Japan, it has to be sorted into 4 size categories. So this was completely manual process. So we try to help them. We said, shame on us, really. We are here, and they're doing this sort of process manually. So, so we get automation of, we started to think about it using vision system, using PLC, trapdoors, mechanism. But the problem is we don't like to damage the fish. Their throughput was, at peak time, they sort altogether 12 fish per second. So we need to sort out 12 fish per second to meet this target, right, without damaging the fish, because it is fresh fish. So we had to think about sensory system, etc., etc. I'll go quickly. First stage says fish size identification. For that, we had to go through optical sensory system, think about it, roller grading system, and the fish fall between them based on size. It's not good. That's good for potato, for whatever, for apples, or computer vision system. And actually, we took computer vision system as the option. Number 1, it is low cost, accurate, productive, non-destructive, etc. And orientation problem. So the orientation problem was how would you do it? Because the fish usually is not a straight fish. It gets wrinkled. Fish can be like that or can be like that. How are you going to do it? So directly measure the fish length, no physical damage to fish. So we came with this sort of system, which is a translucent conveyor belt. So you have the delivery system, and it goes there, you have a camera, and you have light source, and you measure with sorting mechanism at the end with PLC, and actually it was PLC at the end. And I'm not going to go through the technical thing of it here. That was the image processing using LabVIEW block diagram. So first you get the threshold of the fish, and then you have to filter it digitally, and then after that you go through the image processing, and then you take any damage out, you get anything through the threshold, and then you go through it and fill the hole, etc. And you get the image processing through the pixel between 0 and 255. 0 is black, 255 is white. Okay? And as I said, the orientation of fish was a problem, because if you count the pixels to find the length of the fish, you get wrong measurement if the fish is vertical, standing like that, or standing like that. So we had to estimate the center line of the fish. So what we have done is We had two scanning, vertical scan and the horizontal scanning, and with that we managed to get the, for example, here is different, but the previous one you can see nearly the same. So we managed to get the maximum length of the fish. We threw this algorithm, okay, and the result was good. That's the vision system. We have the measurement was about 97% accurate, fast throughput, 3 fish per second, so you can have three lines that will give you 12 fish, which is the requirement of the factory, and can only process 1 fish at one time. And measurable size is limited by the camera window view. You can sort sardine, or you can sort leather jacket, big, or you can any type of fish you like. This half the problem. The other half of the problem, how you're going to sort it mechanically. All right, you identify the size of the fish and the length of the fish. How would you be able to sort them out, the small, the medium, and the big and extra big? So, as I said, we have to maintain the current throughput as industry required. So we came up with this program like a vision system, and you have the collection boxes and you have actuators. Okay, what we found is we use the theory of projectile theory. If you project an item that have initial speed fixed, all right, and the angle of projection fixed, then the curvature of the projectile remains the same, irrespective of the weight of the projectile itself. So, because we could not get flap to hit the fish, 12 fish per second, that will damage it, of course. So, what we had to do actually to throw the fish, all right, and the fish will get this projectile and then build a flap. Has the same shape as this 1.5 meter per second speed, and then the flap will move, all right, if the fish is the right size for this station. So that's how it is, for sorting birds, collecting birds, etc. So this is the flaps, the small one there, this a second flap, third flap. So the fish will go successively from one bird to another, to another, to another, all right? And if it is small, for example, the first flap will open, all right? There is a packet. It goes, digital packet goes from the sensor, from the computer or vision system into communicating with the mechanism itself, and that's how we build it, all right? And there's a module of the flaps itself, and so the pneumatic devices had to read the signal coming from the vision system to see whether this is the right flap to open or not, based on the size of the fish. Okay, so it reads temporary buffer, all right, and write the data first in, first out, all right, read signal from the photoelectric sensor and keep track of the fish through the fourth section, and process information and reduce outputs, and send data packet that carries the fish size information to the next module, and so on. All right, I'll go through it quickly. I'm not sure. Sorry. There is a small video here. I'm not sure I can play it or not. This is. It's 5 minutes video. This is where the fishery company is. Lake entrance in Australia, in Victoria. I hope you like ABBA. Here it is manual sorting. That's how it used to be. Versus completely manual. They have a ruler and they look at the ruler, all right, and just to compare the fish with the size, about nearly about 10 people working or 12 people working on that. So we got rid of that. And with that, that's in our lab. You talk about lab, this is our lab. Where is our lab? That's the vision system. And this is the station, and you have the collecting boxes down there here. That will be a conveyor belt in industry, because that was in that. And this is a flap that has the profile of ejection of the fish at 1.5 meters per second. So consequently, fish glides over the flap without being damaged. So glide over it to the next. And this can be adjusted. This one here can be adjusted and built in here. So the desired limit can be adjusted. Sorry, sorry. Sorry about that. Yeah, I have, but I have to go through it quickly. Well, anyway, you have the idea now. So it goes from one station to next, to next, to next, and so forth. And this is a model of how university, in collaboration with government, can help improve the economy of the region through building more efficiency in local industry. And thank you very much for your attention.
I think we'll be talking business after this, because we have a solar ice machine that is for preserving fish. So let's talk business after this. I'm going to seal this deal. So thank you very much, everyone, for your patience and for eagerness to learn today. We'll be heading out for lunch. So asanteni sana. See you. Godspeed in terms of eating lunch. If you can do it in 20 minutes, be back here. We'll be very glad. Thank you. Having our next speaker, which is all the way from Uganda. And we, just to mention, as Kenya section, again, we are very big in terms of collaborations and support. And we have a number of members from Uganda section here. Ezabo and Tim, if you are here, please, yes. Just wave your hand and say hello. We'll have an interest tomorrow. A round of applause to them. So their being here is a collaboration of Uganda section and Kenya section. So next time when you have something in Uganda, get Ezabo's number before he leaves here, because he'll be very willing to support you as well. So we have Mayur from Uganda. He is a professor at a university, and he's a lecturer and coordinator, yes, at Isbat University. Today we'll be talking about academic research publication and how to avoid paper rejection. So if there's anything we need to know, you'll find out today in terms of paper, you're doing your papers and research. I know we have students who are in their final years here, and even after that, as young professionals, we need to really create the culture of writing papers and publishing, even in your careers. So thank you very much, and welcome, Mr. Mayur. We have 15 minutes maximum, so include your questions there. Karibu.
So, hello everyone, and good afternoon to all of you. Thankful to the IEEE Kenya section and the team for giving me this opportunity to talk about the academia research and the publications, and also to how to avoid the research publications. since it's a student congress and most of us are the students, also to the young professionals. And sometimes it's really important and required to know where to publish, how to publish, and how to avoid the paper rejection. So I hope you will get enough knowledge about this session. And I suggest also to my fellow students to note down few points if you find them interesting for your research work actually. So if you are a student or as a scholar or a scientist, you know the struggle of getting your manuscript published in high impact journals, also the pain if it gets rejected. So what happens, like if you're a research scholar or even a final year of student also, you have done a lot of good project you have done, but writing a paper is different than writing your project report. So both are different things. So when you write a paper, you need to take care of many things because almost around like 50 to 70% of papers get rejected because of the poor publications, poor writing, poor way of methodology to be followed. So what criteria need to be required to be followed so that the paper should not get rejected actually. So what are the reasons for the rejection of the manuscript and how you can prevent them? Since it is very important for an academia, even either your faculty or a student or a research scholar to publish your paper. So what happens when you submit a paper? So after submission, to make a decision to send the manuscript to the reviewers. Now it is in the hand of editorial board actually. So editorial board is the one who's going to take care of the decision that either your manuscript is going to be forwarded to the reviewers to take a look and to see the acceptance or rejection of the paper, or without sending them is going to revert back to the author or even on the same day itself. So that I'll show you maybe in the next few minutes. What is the meaning of that? So the editorial office, what they're going to check? They're going to check about the manuscript, the aim and the scope of the journal, that the way the paper you have sent, is it on the right track or not? Suppose you are working on the power electronics field or electrical engineering, and then you send your paper to the photonics journal. So before sending the paper, we need to know what is the aim and the scope of your area and of that journal where you're going to send it. Author follow the journal instructions and guidelines properly. Editorial office will return the manuscript that do not follow the instructions, which is the aim and the scope and the instructions of the journal. The editorial office prepares the authenticate report to plagiarism also. And this is what most of us, the students, those who are in the final year, please take a look when you're writing a manuscript, the plagiarism. Please do not copy and paste just directly from someone's author's work. So please rewrite in your own words, or better write your own manuscript your own ways so that you do not copy from any of the sources. So the editor or the senior editors, what they do actually, they consider the issue raised by the editorial office, read the manuscript and assess its suitability for the reader of the journal and make a decision to send the paper to the reviewers or not. So it is in the hand of the editorial board. So sometimes what happens when I'm talking about the paper rejection, sometimes I send a paper to a journal and the same day itself it comes back to me and says your paper got rejected. Now it is your like throughout 1 year of journey, you have done a lot of work, you have collected research papers, you have done a lot of work, but the same day you find my paper got rejected actually. So to make the decision to send the paper to the manuscript to the reviewers, it need to be taken care that the clear research aim and objective need to be there. Scientific research contribution. This is the really important part when you send the paper to this essay journals, peer-reviewed journals. They're going to see your contribution towards that area. Clear research motivations. So what actually is your research questions and are you able to provide the answer for that? Significant important research ideas that is relevant to the reader of that journal actually. That's what I said. Suppose you're working in the field of like power electronics, do not send it to the journal related to the optical communications or just because of your friend says, hey, I'm sending it to this journal, okay, let me also send it to this journal. No, it's not like that. That you send it because of your friend is saying. You send the paper which matches the aims and the scope of that journal where you want to publish. So if it follows, then the editor will send the paper to the reviewers. Or if it's not like that, then the paper will be going to the desk rejection. So what do you mean by the desk rejection? Even the editor, without sending that paper to the reviewer, it's gone back to the author again, says that it's not matching to the aim and scope of the journal, and your paper is rejected actually. So, what is a journal desk rejection actually? A journal desk rejection means that the journal editor rejects a manuscript without being sent it out to the reviewer actually. So, the first task for all who are the researchers here need to take care that we should always follow the instructions and the guidelines, aim and scope of the journal to whom we want to send the paper. And it should be very clearly mentioned in that paper so that it shall not go to the desk rejection actually. Because since it is your throughout of years of study, years of research work, and you do not want to reject a single day itself. Since I have experienced this, so I don't want you people to experience this thing of the desk rejection actually. So a journal desk rejection does not always mean that a manuscript is not good enough. No, your work done is good, but not in the right journal actually. It means that the manuscript is not fitting for the journal. It's not like that your work done, what you've done is not good. It is good, but not for that journal especially. So there are potential benefits from the desk rejection. Now what is that? Since as soon as you get desk rejection from the respective journal, then you find which journal you need to send it. So better you go to that journal to publish your paper. And also the authors do not waste their time to keep on sending the paper to the same journal which is not even relevant to their area of research works actually. So how long does it take a desk rejection? So it takes usually like a 1 day time or also minimum of like some 10 days of time. Sometimes it takes even more time, but I got a reply within a single day of time actually. I worked on photonics, I sent it to some other journal and this is your paper rejected. Now it was my like 1.5 year of my PhD research work, and a single day I sent them my first paper and they said rejected. And I was very happy, wow, what kind of work I'm doing. But you know, the things are not in our hands, you know, because we as a researcher, as a student, we can do our research work, but getting published is a different task actually. So, what are the reasons for a journal desk rejection then? So, the manuscript maybe does not meet the quality standards of the journal, mismatch the journal's scope, submit the first draft. You know, when we write a paper, when we see the template of the journal and we just write a paper, we just prepare it and we just forward it. I don't know in what hurry we are to send the paper to the journal. So it's not like only just first draft you prepared and you forward it to the journals. No, take a look, a paper from starting to the end, read it twice before sending, show it to your supervisors, maybe your final year, your project supervisor, project coordinator or the faculty. Just show them once, then only communicate the paper. Don't be in a hurry to send the paper and just wait for the rejection actually. Resubmission of the rejected manuscript to the same journal, that is also not possible. Plagiarism need to be removed. Lack of novelty and significance. Also, lack of theoretical consideration and support. What happens now? Some of us, what we do, only just do kind of simulation studies. We take a software, maybe on the MATLAB or any simulation tools. We just design something and we say it is my own design, this is my novelty. But how do you prove it theoretically also need to be taken care. Means also you have to do the review analysis with other papers or other authors, those who have done the same kind of work in the previous histories, so that you can also say, okay, this is the way I have changed my design, this is the way I have done the comparative analysis, so that my paper shows me some better results over here. So how to reply a journal desk rejection? Now, first of all, my experience is do not respond to the reviewer that, you know, why you have rejected my paper, I studied for the 4 years, this is my final year project work, how you rejected my paper, this is my research paper, I have done good job. No, please do not respond such kind of questions to the reviewers, because they know why they have rejected. It's not like this is Mayor, yeah, hey, I reject your paper. It's not like that. They see the paper according to their journal requirements, then only they reject your paper. So first of all, do not respond. And if you want to also respond, please be nice to respond them actually. You know, you can say like, thank you for your valuable comments. I shall go through with them for this and for future manuscript. Thank you for also for opportunity to submit my paper to your journal, something like that. In some good words, you know, because if you are going with the good words will come to you actually, right? So don't say the bad words to the reviewer actually. Because in the future, since right now in bachelor's, when you go for masters and PhDs, if you want to send the paper in the future to the journal, they will not allow you even to send the paper to those journals. So, what is the next? So, if the manuscript fits with the journal, but the editor raised a number of concerns, please consider the editor's comments and submit again Only if the editor offers this opportunity to you. If this is you, please correct them and submit back to the same journal, please submit. If it's not, make the suggestions, whatever the editors have made to you, make them correct and maybe forward it to the some other journal which fits for your respective journals. And how to avoid the journal reservation decision actually. So find the right journal, that is the first thing actually. So check the list of references in your paper. How do you find the best journal? 2 minutes of time. Yeah. So how do you choose the best paper? Now, the paper which you are following as a reference, take a look on that in the last 5 years, those authors have published in what kind of journal. So you'll find, okay, I'm working in photonic, I'm working on power electronics, I'm working on electric, I'm working on this field, maybe biology, medicine. So you will find the respective, that this kind of paper is being published in this kind of journals. So you can follow those kind of journals and see their aims and scopes, and then accordingly you communicate the paper to those kind of journals. It's easy for you to find where to publish actually. Because when I came for my PhDs, I was not aware about the publications and all. Now my guide says, Mayur, find the journals for you where you want to communicate. So I learned the way how to find a journal. Because I sent a paper, it got rejected. I sent second time, also get rejected. I said, is there an issue with my research work, or I'm not writing well, or what is happening to my paper? So what we have to look into that, then I find, okay, there are certain journals like IEEE, Photonic Journal is there. I tell some, maybe some other names, maybe like Quantum Electronics Journal, Photonic Communication Network Journal. So there are respective journals I seen, my same kind of work was being published with these kind of journals very frequently in last 3 years. And you won't believe now I have 7 essay journals in the related peer-reviewed journals actually. So that's the way I've learned like how to publish and where to publish, because it saves your time to avoid rejected again and again. So better you communicate to the right journal, so it publish as soon as possible to your work actually. So also be aware about the journals, what is their specific orientation, their interest, their references. Also be aware of the journal style, like the way they want the paper from you. Like some papers, if you go to some journals, they specific tell you, this is our template, please follow it. Some journals just say, give us your manuscript in double column, single column, what the way they want from you. Please communicate in the same way so that it saves their time also and your time also to keep on changing the changes which they suggest to you again and again. So, how do you write a good manuscript then? So, first decide your title. Before that, finding a title, find a good research question. Either you're in the final year of your project work, you're doing master thesis, you're doing PhDs, either you're faculty, find a good research questions. Once you're okay with that questions, then you work on that areas actually. And you take the help of your seniors, professors, like the mentors, take their help so that they can help you to find good research questions. Then write a good introduction, follow these things in writing a good introduction, write a good literature review, find the hypothesis development over there, so that what kind of things not to be done or how to question someone if already have done that kind of work. Then research method is a very important part to write the research method. Like I'm doing this work is being related with these many areas, that's why I'm following them as a reference, and always cite those papers to whom you are taking as a reference to reduce the issue of the copyrights. Then also do the additional analysis like other findings, do the key findings, do the research analysis, the ways of comparative analysis. Suppose I've designed this motor give me this much of efficiency, but I'm not the only one who have designed this motor. Earlier people did this kind of work, they made these many changes, this was the efficiency, this was some other parameter, that's the way I have made changes, then I have done this kind of analysis, and that's what I say is, I use this method, this is why my paper has a better results. So you need to always do the comparative analysis at the last of the papers, because most of the where I have published the papers, they find the comparative analysis, because the work need to be compared what the previous author have done in the last 3 to 4 years of publications. Also write the conclusions and then references to your papers. And the references, I suggest you all again, to whom journal you are communicating, at least take 1 or 2 reference from that journal, because that journal is frequently publishing, it gives your more chances to get published into that journal where you are publishing your paper. So that is my suggestions, and that is from my end. So thank you very much for listening to me. I hope you had an understanding about like where to publish a paper, how it is good to write a paper, And if you still have any questions, feel free to ask me, or I'm sitting already here, so you can also discuss to me in the break time. Asante.
Thank you very much also. He's kept time very, very well. So Asante Sana, and we'll be reaching out. He's very available for questions as well. I recently got a paper rejected, so I can relate. And then another one accepted. So the journey, as he said, don't give up on the first one. Keep applying, keep trying, and keep learning.
You won't believe my PhD's first 3 papers got rejected. I'm telling you again, in my 4 years of journey. 1.5 years, I just took a time to review the reference analysis. It's not like, I'll tell you, some people will come to you, they'll say, I joined for PhD, within 6 months, I got an SCI journal paper. How come? 6 months of time it just take to go through with the, the review analysis, take the references. So don't go in the wrong findings. Someone has published, it's not, it may be a miracle kind of, don't follow such kind of things, Go with the step-by-step process. Papers will come to you, I'm telling you. I got 7 essay journal paper, you can search by my name. It will come, but it takes time. Some essay journals take even 1.5 years of time, but it will come to you. If your work done is good, have some patience. The research shows you to have patience. Paper will come to you definitely, if you're on the right track. Thank you very much.
Thank you very much. We'll reach, in the interest of time, please reach out to him in case of any questions after this session. Thank you. So we are moving to a ramp session, and just before we call the speakers as well, we've had a week long of, who knows what has been happening this week? Entrepreneurship Week, IEEE Region 8 Entrepreneurship Week. So we are focusing on also having our students and young professionals understanding that you can innovate, you can create, you can actually come up with your own job. We recently had a student, a new graduate who, not a new one, he was, anyway, he posted on social media and said, I'm dumping my papers. You know, the way you dump a girlfriend or boyfriend. He said he's dumping his papers because he's not finding a job. So what we are telling you is that you can be innovative, you can be creative, you can be entrepreneurial. We call it techpreneurship even nowadays. And this is a session that's going to address that. It's called a ramp session. Our moderator for today is going to be Kitinji Muriungi. Again, he's our young professional chair, and he's also the ambassador for, not ambassador, the lead in Region 8 for Entrepreneurship Week. So we are in very good hands. In terms of our speakers for today, so are you excited to get into this ramp session? Yes? So we have Sarah Wambui, the Deputy CEO of E-Mentoring. As I call you out, please make your way to the stage. We have Peter Kipkoech of DevOps Engineer at Safaricom PLC. Mayur will have you back with us. So we have Mayur Kumar, who is the lecturer and coordinator at Isbat University. We have Florent Guya Muture, who is PhD candidate of NextGen SSRC Proposal Fellow. We have Frederick Wahome, the Deputy Chairperson of KCSFA and CEO of SecureNet Technologies. So welcome all. Again, our moderator is Kitinji Muriungi. A round of applause for them as they come up.
Good afternoon. I hope all of us are full. Yes? And we've actually enjoyed the meal. Yeah? Yes. It's great to see that. So this is a test session that we are having, and I can bet probably it has never been in Africa. A ramp session. And what is a ramp session? A ramp session, this is a panel session. We've had keynote session. We've had plenary session from Mayur. But, and also we've had all those workshops, special sessions, and all those things. But we've never had a ramp session. And this is how a ramp session goes. So our topic is analysis of real challenges and opportunities from the hyped trends in entrepreneurship and innovation in Africa. I'm just a moderator. And then, this is how it goes. So, a RAM session is a cocktail of keynote, plenary, special session, and panel session. So, najua sasa, I'm starting to break the laws of conference from the industry perspective and also academia perspective. Especially academia, we don't want confusion. We just need to do one thing. And then number 2 is it's a battle of the mind. A battle of the mind in this way. We want to see analytical sense. We want to see critical sense. We want to see contextual arguments. Proactively participation. Not from this side and this side alone, but both sides. And the last thing is a ramp session is actually meant to steer the audience, to steer the participants in a more realistic and futuristic path. So, and the last point is what do you, okay, I missed that. It's what do you know that we don't know? That is the question we normally ask ourselves in a ramp session. Pardon for that. So we are asking them, what do they know that we don't know? And then we are asking you, what do you know that they don't know? And I'm in between here to moderate. And the last thing is speaker takes 2 minutes to make a point, and then audience responds within 5 minutes. And all of us, we should be in the context of that topic. I'll give a case scenario because I know this will be hard. And we are testing it in this Congress so that we can start it and we can keep pushing it forward. I had an experience in ECOC 2022 in Switzerland last month. And that is where I bought that idea and I brought it home. I've had the same experience in a conference and it was also nice. But that one in Switzerland, it was like the best. So this is an example. We have 3 cases here. Moore's law is dead. Someone here will say that. And then someone will come with an argument that she might not be aware of. Someone else will say, that is a challenge, but now I can see an opportunity in this area. IBM is actually working on this horizontal, vertical kind of configuration of the transistors so that we can still push the limit of same transistors and keep coupling more and more and more. But someone else will recommend, that's fine. Now the third speaker, that's fine. But I would recommend we keep that going, but from our side, we can start looking at other things like photonics, where we are no longer interested in transistors, but we're looking things to do with wavelengths, waveguides. We're looking now lights. We are no longer interested in electronics, but we are interested in photonics. We are no longer interested in electrons. We are interested in photons. Jerry, that's the path that we are going. And to get our self going, I hope now we are together, and that is the discussion we are going to have. So to start with, allow me to jump Mayur, because he has been on stage, and we will start with Sarah Wamboi. So Sarah Wamboi, she will be making a case on mentorship and softer side of professionals, the human touch. She believes we need this for us to innovate. So, Sarah Wamboi, karibu. 1.5 minutes to make your case.
Good afternoon, everyone. Yeah, my name is Wamboi Ndegwa, but Sarah, yeah, baptism. I'm the Deputy CEO of E-Mentoring Africa, and I'm excited to be here. Never been in a room full of so many engineers. I'm not an engineer. So today I'm making this point that engineers need a human face. Engineers need a human face. What do I mean by this? I mean, when engineers are presenting themselves, they better present themselves behind the screen, but not in person. So how do we break the challenge of engineers to be able to have the social skills, to be able to have that professional, not professional look, because we all have our own different professional looks, but how do we give the engineers a human face? How do you interact with other people who are not necessarily engineers and you're able to pass on the message to them? So I don't know whether you have human faces, but for me, we need to give engineers a human face.
In short, she hasn't brought it out clearly. She said, you engineers, you are really good in making things that make you feel good, but you don't really present it so nicely, and you don't even make sense to the people that you are designing it for. And the first person I like to hear from is someone that I know, because he calls himself Dev Ashton. Let's hear from Dev. Yes? And I need your response to be either you agree that you need that human touch, or you still believe I'm fine as a tech guy. I don't actually need that.
Hello. Yeah, my name is Ashton. I'm from Kenyatta University pursuing biomedical engineering. As you've said, my engineers are going to Surangoom. Of which I agree with her. We are focused so much on developing the tech side of stuff, and then you don't really go into how to present it to a client or how to go about the business process of it. You see? So I believe you're doing a good thing with the mentoring people in the workplace and also those who are transitioning into the same workplace.
Thank you, Ashton. Thank you. But still, I'll push the question back because I've met so many senior developers, senior engineers who feel they are comfortable in the server room, but not in the boardroom. Let's get to hear someone with that mindset, at least share that. Yes, please. Pass it back to that lady at the back who is tapping the dready or other thing. She has a point, but she can't remember it. Yes, and then we will get to hear from her, and then we will push to the next person. Yes, that lady. Oh.
I believe we got the wrong person. Someone else is interested in answering.
Yes, give it to someone here. And we need to get your perspective clear. Clear perspective.
Thank you. Hello, I'm Valerie Ogola from Multimedia University. I'd say it's true that engineers need the human face, and a way of integrating this is when working through your projects. For example, let me give an example of just a short example of a project we're doing. Let's say we're working with an app for the mechanics. The way of bringing in the human face is actually diversifying your team. So if we as the engineers, we do not feel comfortable talking, you could bring in board a person who has done something on design thinking, and so knows how to present the idea and solution according to the people's need, and also integrate to interview the mechanics.
Thank you. I think I've gotten the point, and that is the perception I wanted. So at some point, yes, you are agreeing that all engineers need to be as loud as they can, but of course, you are forgetting kuna kitu inaitwa teamwork. And teamwork at some point says, you don't need to know everything, but you can be the face, and then you can have the tech guy still remain the tech guy, and of course, the rest of the things proceed. I will reserve one guy, maybe have him later come in, probably in the next phase. So the next one is, I'll proceed to Flora Nguye, so that she can make a case around the innovations. And maybe something I'll touch about here is, someone here was talking about IEEE, and she was trying to say, you know, I'm an architect, and this is electrical engineering guys here and doing these things, and I don't even see myself where to fit in. And maybe before even she talk, I'll give that student a case. Imagine an architect who could use VR and AR into designing things and even drawn into doing with civil engineering to just do the mapping and all that kind of stuff. And that, with the mind of that kind of a person, if he or she comes into the IEEE and meets the computer science, they can do magnificent projects. And this is actually happening. It's actually happening. So with her, let's see what kind of magic she brought on board as she make a case about what she's doing. Thank you. 1 minute.
1 minute. Yes. Okay, he's answered the question already, but let me do my best to address this critical, analytical thinking that he's challenged us about. I am looking at a disruption or transformation in museum spaces. My challenge is that artists, designers are really well matched with engineers, with the techies, with the DevOps, in order to create belonging in an urban space, right? Think of a cultural space such as a museum. I don't know when last you were in a museum. Hands up, how many have been in a museum this year? Liars. No, I believe you, I'm just pulling your legs. But can those spaces do the work of creating identity and belonging to a space like Nairobi? I want you to think about it. So those guys being the techs and the designers. I heard someone talking of design thinking, so my minute is up.
Thank you. So she's trying to tell us that despite you being a techie, you still need to have a fun. You still need to have fun. You still need to know music. You still need to know how to draw. And not engineering drawing, but creative drawing. I need to get your response on that. And as you respond on that also, I need to get like your perception of how do you differentiate engineering drawing and the kind of drawing she's talking about. How do you revolutionize things? We've seen Spotify. I'm talking so that we can get hands up. And yes, good. Go to that. Beryl. Someone else on this side? And I'll get to hear views from one person. Just before you pass that mic to that guy, there is one guy I've worked with. He's one of the most amazing designers, mechanical designers I know. And while we were working with him, it was really hard for him to see the other side of things. But by the time we are done with the project, he actually testified how transformative that experience has been. And I'd like to hear from Newton first before we pass mic to that guy. Newton, yes, tell us that experience from a mechanical transformative designer into seeing other things. Quick, 30 seconds. You can pass the next mic. We are trying to, Chaltu is counting minutes on me, so yeah. The other mic, it's not working, guys. Wow, where is the tech team? Okay, pass this to him. I think I'm loud enough. I can wait for the mic. And the rest of the team need to get ready. I've seen hands not on this side, so I'll be pointing to you next side.
Yes, thank you, Kidiji. So my answer to that question is the engineering design should really consider both the technical solution of the design and also the how the consumer of that product is going to be feeling while using that product itself. For instance, when it comes to maybe something like the product design of an artist, it entails the feel or the aesthetics, how the consumer is going to feel while using the product. But the engineering design itself, it focuses on the technical solution of the product.
Hi,
In museums in the digital age, from what I understand, museums actually have art pieces that are mostly cultural or maybe show the heritage of a certain country. So in the digital age right now, we have NFTs, as the lady who was from Visa actually said. So NFTs actually come in to kind of like put these art pieces in the digital world, in digital form. So NFTs can be pictures, they can be music, they can be virtually anything. But then since they're in the digital space, you can actually get so many people viewing your art, and you can also get that people are buying your art, yeah? And it's actually owned by you, so no one can replicate it. So I think in this age, museums can have a better, what can I say? Better outreach and better impact in the blockchain and NFT space. Yeah, thank you.
When the guy goes and sees that the titanium, was it in Belgium? And then he says, where did you get this from? This is blah, blah, blah. And then he says, no, you stole this from Wakanda. How do you know? Anyway, for those ones who have not watched, that is what she's trying to mean. You can't steal it, you can't fake it, you can't put a bad mark on it. I don't know if the mics are yet fine. Still not working. Okay, pass it the guy. And I hope you can run, eh?
Okay, my name is Ambani Godwin. I'm in JQuat doing electronics and computer engineering. Now, about the museums in a digital age. And basically the message I'm getting is that we engineers need to express our engineering in a way that resonates with what the society can get from us. We need to present our ideas in a way that the people can appreciate our work. But at the same time, there is a group of us who are really trying to struggle and find what is good, what can we do better outside the engineering. Because for me personally, I'm trying to find a talent that I can do, and I've been thinking for it for a while, and I've tried many things. I tried singing the other day. I also tried drawing, as you have said. Engineering, drawing, that unit really harassed me. And I cannot, and you are saying that I do this other drawing, and I don't even know where to start. So basically, okay, just to wind up, how do we express our art? How do we express our engineering in a better way, especially for us engineers who do not have many talents, let me say like that. Yeah. Thank you.
Someone else.
Oh, thank you very much. I hope I am visually homogeneous. Yes, I'm Onyango Lennox Ndeda. Yes, the Lennox company that is distributing laptops. If you saw that spelling, that's the spelling of my name also. I'm a student at the Tech University of Kenya, currently pursuing Bachelor of Engineering, Civil Engineering, 5th year. We, of course, as engineers, we do a lot of statical determinate structures and seismically dynamic phantoms, like Panari Hotel. Those are consequences of what the course I do. Yes, now responding as far as art and engineering is concerned, dating from times of Leonardo da Vinci, the Ksyp on canvas and oil on canvas, you will agree with me that we engineers suffer what we call the genius curse. What some of the major poets like Michael Okigbe of Ghana will say, the curse of the genius. We tend to think that we want to do things that other ordinary and perhaps superficially intellectual people, I mean rationally irrational intellectual cascades of people cannot get easily. Therefore, art and engineering is something that must be integrated for us to ensure that we don't get any kind of disharmony, disconsonance, and above all, superficial chaos. In my first response, because of time, I want to stop there. Permit me to say that we have to embrace drawing culture so that it can be represented by entire demographic data as far as the quest and the quest of myriads of coherent controversies with the tincture of engineering is concerned. Due to time, permit me to stop there.
That is a ramp session. That's a ramp session. The other one was someone trying to respond to a lecture. That is a ramp session. That's how a ramp session should be. To wind it up, it's as if he has stolen, he has took my mind off. I wanted to wind it up with what Leonardo da Vinci did. Leonardo da Vinci drew an aeroplane before the Wright brothers were able to build it. Are we together? And to maybe make Chaltu fall in love with the discussion we are having, there are two guys who met. One of them was Einstein. I'm forgetting the other one. And then the other guy told Einstein, you know, I'm always amazed by the way you use your mind, blah, 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 blah. And Einstein told the guy, you know, what really amazes me is the kind of things you do without even saying a word, and people can actually understand what you're saying. Lastly, I will go to Elon Musk, whom all of us talk about. Elon Musk, I know for sure, he bought Twitter not because of anything, but because he's a meme lord. Okay, to the older senior, to the seniors in the room, what we mean, kuna meme. Kuna ile inaitwa meme. Yes? Where you see someone does something and then it's translated into something else. And if the richest man, an engineer that we all praise, can actually resonate to art to that level, the scientists that we all praise, instance, the Leonardo da Vinci that we all praise, who are we to actually say that I can only be an engineer full-time and nothing else I can do? Lastly, you will hear this. Almost all Nobel Prize winners, especially those ones who have done things to the level, especially bringing in engineering and something else, they have had a great touch of engineering and arts. So if you see whatever you are doing doesn't come out clearly, bring in art. I will pose it at that. The next person I like to talk to is I like to go back to Mayur. And Mayur makes this statement. Mayur says, for us to hack the thinking that we have around innovation and the trends that we are seeing, academia is the savior. So you don't, Njeri, you don't cook, you don't bake half-baked graduates, put it to the industry and expect industry to finish them well. In short, Mayur says you need to, okay. Let's him make the point with justification and then we respond.
Thank you, Ketanji, for this opportunity again. I do say that, you know, every institution should have an entrepreneurship cell, should also have the innovation club, so that the students who are in the final year or those who are still doing engineering or any of the course should be knowing what the entrepreneurship is all about. Because I did my 4 years of engineering and never studied about the entrepreneurship in my 4 years of course. So I do believe that this kind of subject called entrepreneurship should be mentioned in our engineering courses. Also, there must be an innovation club in every institution or the university where the students can take up to their project to a next level where they can serve to the society and they can also be an entrepreneur.
Thank you very much. Now, I will reframe it again and say this. I think we have so many parts. We have those people who will always become entrepreneurs for life, and that is where they find grace and peace. There are people who find grace in government. There are people who find grace in private sector. There are people who find grace in doing their personal business. Now, I want to hear that kind of thinking. Is it a must? Yes? Is it a must? And I'll start this side. I know you will speak, but let's have Prof. Hendrich from back respond, and then we can have Njeri. Yes, Prof. Is it a must? And do we, all of us, have to go through the same path of entrepreneurship?
Can you just repeat that again? Is what a must?
So he's saying academia is a savior, and his point is every school need to have entrepreneurship and innovation class. My perspective is, I'm just trying to bring the discussion on this side. We know people who cannot innovate. Not really they cannot innovate, but they are really good in other things. We know people who cannot lead things, but they can follow things. So your argument around that, just either to support or whatever it is, academia is a savior. Thank you.
Thank you very much. I think I'll be controversial. I will say that I disagree to an extent. I think, of course, it is important. I think as a baseline, I think I had a course innovation in my first thing that I found very useful. So as a baseline, I think it's beneficial, and I think in that sense, everybody can benefit from that. But there's also nothing wrong with being the kind of person who, you prefer to work for an employer, and you're happy to be in the environment where your tasks are given to you, and your job is well defined, and you're happy to do the tasks that are given to you. But of course, to open your mind, I think it's good to do something like that, to learn about innovation, but it's not a must in terms of your career that everybody necessarily has to be an innovator.
That is the ramp section. Analytical, critical, and actually sharing your mind. What you know that we don't know. That is a professor speaking. Clap to him. Thank you. Let's hear from Daktari Njeri.
My name is Njeri Garoya, and the very first question that I would like to actually bring out is, do you even have to actually go through universities? Do we?
No.
And if you're my student, you say no, just get to know that I'm going to get on zero at the end. But anyway, the reason why I'm actually asking that is because I usually say an academic space is a space that you can do much. Not only just going through and getting A's. I usually say it's better for you to be an average student, but also be displayed. Okay? Then you getting straight A's and there's no display at all. Right? Because that means you're able to be taught something. And I actually resonate with what has been spoken about by Manur. We're talking about innovation hubs. These are spaces that you can actually come in with your perspective. Maybe someone from School of Computing coming in with a perspective, engineering coming in with a perspective, and someone from creative arts coming in with a different perspective. And what happens in that particular room is just amazing. So what do you have? Do you have to sit down in silos as guys in School of Computing and say, we are just going to think about a solution without even necessarily thinking about any other person from engineering? I love the way the guy who had very heavy words, okay, Lennox, yes, yeah. If only I can actually get Lennox to actually merge with guys from design school in Tuk, yes, I am so sure a lot can actually come out from that. Okay, so do we need innovation hubs? Yes, we need innovation hubs in schools. Yes, we need students coming in together, not only just thinking of a place that they're going to actually go through 4 years, and then once they're done, they get a paper, but what else can actually come out, can you actually get from these particular spaces? Interact, get to know much that you can actually do. And definitely, entrepreneurship, it's something like gig work can actually be done, and especially with the context of apparently you guys, you're much of gig works and the deep web, that I don't want to talk much about. These are the guys who are riding Audis and all, getting to, at least nowadays, you're thinking of buying land in Naivasha, than just like spending much. It's good. So gig work is stemming out from entrepreneurship when you're actually in school. Yeah.
That is a RAM session. Clap? Yes. You know, it's very weird, and allow me to say this, it's very weird to hear someone with PhD actually question whether it's important, is it necessary to have it? And that is what a RAM session is all about. You look at it from different perspective. And you know, if a student would have asked that, would have said that, it will maybe mean something else. But hearing it from someone who has it, it's really nice. So allow me to pause it at that because of time, and we go to the next speaker to make a case. And his case is about leadership in techpreneurship and fourth industrial revolution. And welcome Frederick Wahome. 1 minute to make your case. And I want it to be as controversial as possible.
Good afternoon. Thank you very much for this session. I'm here courtesy of Vincent Ocheng from TUK. I'm in cybersecurity. And this afternoon we are here. And the one thing that we have seen from the industry, being there for the last 10 years and running and trying to mentor young people from the technical side, I can authoritatively say that most of the students, you are the ones supposed to come with innovations. But now the challenge that we have, most of your innovations, you download them from Wikipedia, that is number one. You also go to Stack Overflow, meaning that after you come out with these innovations, they are not sustainable. It is not something that you can present to the industry, and then we can be able to develop together with you. Number one, leadership within the techpreneurship. How are you going to become a techpreneur if you have not learned the art of leadership? Why? Because if you are the one you have innovated and the foundation principle of your innovation, you downloaded source code from a website somewhere, meaning that you don't really understand. And what means that you first require to administer a soft skill in terms of leadership. Because even the Bible says that a blind man cannot lead another blind man. Where are they going to go? What is the direction they are going to follow? So my case is this. The innovations that you are bringing out to the industry, they are not very genuine, very genuine innovations. Number two, can you first develop your leadership skill as a soft skill when you are still a student? Thank you.
So, thank you very much. And before I come back to you, I want to hear from the most prestigious guys that all of us, especially Vincent, is actually proud of. The guy who put the name of Kenya at the map. The guy who have won accolades and accolades and accolades and accolades. The guys who have awards more than we can think of, and they had innovation. So, was your innovation actually merging to his thought? And then, in line to that, I'll also like to point out something I've realized. Allow me to use this word. This guy says he's from a cybersecurity space, and he doesn't have a hoodie. Think about that critically. Yes? Yeah. Alan, maybe you can respond to this. Was it worth it? Yes? Alan is here. Was it worth it? And then we will go back to the gentleman in front of you here. Quick, please.
Good afternoon. My name is Alan Koish. Yeah, sorry. I'm the chair in your section. So to respond to your question, first I want to say that, as you said, I want to disagree because you said we download innovations from Stack Overflow. We don't do that. Kenyans, we do believe that we are very innovative. Just go to any campus, we find very nice innovations, not from Stack Overflow, but we use tools like Stack Overflow just to augment our knowledge. So we are very innovative, and I, being part of a team that took that challenge and innovated, most of the things in Stack Overflow never even helped us. We had to calm down and research, come up with our own innovations, build our solutions, and now as I stand here as someone who can tell you really that sometimes when people limit us to Stack Overflow, we feel bad because you've done beyond Stack Overflow. In fact, we have added some information to Stack Overflow for those who want to make it.
Powerful, powerful, powerful. That is a RAM session, right? That's a RAM session. So, before you speak, I want to make, maybe Esther understand this. Esther, there is a meme that says, two graphic designers meet and say, you guys stole my art. And then two programmers meet, hey, your code is awesome. And then guess what they say? Dev, wanasemanga nini? That is a meme. Everyone has its own understanding of it. But you know, what he's saying and what Alan is saying, it actually has truths and forces, but at the middle, it depends on how you translate it. Let's hear our last responder here as we move to the next one, Guy. Yes.
Ladies and gentlemen, all protocols observed, good afternoon.
Good afternoon.
Yeah, so to add on to what he's saying as a point of agreement, in the morning we had a session where we had some pivot charts, not really pivot charts, but graphs that were illustrating the transition, one, of the top richest people, and two, the countries, let's say the highest GDP or maybe highest rate of development globally. So out of that we will reflect the same and build it up on what he's saying, in the perspective that if we would take the same learning points from people who have already carried out successful innovations, naturally from their own hands, from their own sweat, how did they do it? How do they build up that foundation? And secondly, creating that environment in which people can be able to foster. So back to, we'll start from the very foundation, the education system. How is the education system compared to ours? For example, not really stepping on this one, 15 years down the line, you're studying biology, but you're intended to be a civil engineer. Where do they, yes, they match, but there is need for that specificity so that you can be able to become as innovative as you are. Second dimension is that let us train people to learn the hard way, not really the soft way.
Thank you. Yes, so I've gotten two things. The first principle thinking, which I agree with, but since this is a RAM session, I will not allow you to speak about biology while someone is seated there who is a biomedical engineer. Thank you. A RAM session. That is a ramp. A clap for him. So the last guy, unfortunately, I know Charlton now is waking up. He was asleep and he wants now to put me out of stage. So the last speaker here is actually a DevOps from one of the finest brands we have in Kenya. None other than Safaricom. The finest. And you know what? This guy was my classmate. And I know how brilliant he is. But out here is telling us that AI and ML, it's just a hype. Let's hear from him a case. Please, build your case.
Thank you, Githinji. Let me do justice to this. I believe, not entirely, but I think machine learning is overhyped. So in 1950, Alan Turing published a paper called Computing Machinery Intelligence. And it started that conversation of artificial intelligence. But every year we sort of like have like some technologies that are more popular than others. And right now, machine learning is the in thing. So if I walk into a table and I start talking about machine learning and my models and this and that, guys will come to my table and they leave Githinji's like Lennox table on civil engineering because it's kind of like an archaic technology, right? And there's a hype to that because you see most people are promising that which they cannot give us. Of course, machine learning has given us things like, for example, Spotify, very good recommender for your songs. We have even the speech recognition by, say, for example, Google Assistant or Bixby. So they offer that. There is Tesla right now. You can actually drive autonomously or you can have your car drive you. Yeah, but then if you look as a DevOps engineer, for example, I want to have sleep. I want to sleep at night. I don't want to be woken up at night being told like M-Pesa is down. Why can't we have machine learning solve for us the challenge of that intelligent monitoring of our infrastructure, for instance, and actually give us that value? So I believe machine learning is is overhyped, so to speak. And actually, Gartner, who is an authority in terms of the reports, there is a Gartner, something is called like a Gartner hype cycle. Maybe the next slide can show that. So it really starts from innovation trigger, and then the peak of inflated, and then the trough of disillusionment, and then a slope of enlightenment before we go to the plateau of productivity. And I believe right now, we are at the peak of inflated expectation. We believe machine learning can give us more, but we are yet to leverage on that value. Thank you, Givinji. If you agree, be on my side. If you don't, disagree.
Yeah, I'll pass this mic to someone who deserves it and someone who challenged us. The beauty of connectivity and the beauty of interconnectivity is that you have to connect everything so that it can make sense. And I'll pass it to Prof. Prof, you told us we need to speed up. And he started his statement by mentioning 1950s. So for those ones who don't know, this AI thing we are talking about, it's actually started in 1950s. It's only that the environment was not ready for it. Now the environment is ready. That's why we are seeing that hype. Prof, do you think this is overhyped? What is your take?
Yes, I don't understand a little bit.
Okay. He's saying all these things that we're talking about, it's just a hype.
Yeah?
Yeah, it's just a hype. Like it's a hype. If maybe you don't have a statement around it, you can look around the room and you can pass the mic to someone that you believe he can. Yes. Thank you.
Okay, it is a hype.
Why do you think it's a hype? Thank you.
Well, I mean, I'm not sure what we're trying to do here exactly. We're trying to create a controversial issue out of some facts on the ground. Is that right? Or am I wrong? Yes, we're trying to create a controversial issue of some facts on the ground. Okay, the fact on the ground is that technology is progressing. Engineers need to be communicator. We have a lot of examples of that. Leonardo da Vinci, who was an artist, who was an engineer. The first class I had in engineering, I teach them about creative design competition, in which they had to do teamwork and communicate and do presentation in the first semester of the first year in the engineering course. Because communication, it is a paramount for everything. If you have the most brilliant idea and you don't know how to communicate it, it's not good. It's not good to go anywhere. So this hype cycle for emerging technologies, I'm not sure why it goes down. I think it has to go up and up. It comes to a saturation point. It may come to a saturation point at some stage or not. I don't know. Yeah, technology is progressive, whether we like it or not, and it's not going to stop at any level, whether we like it or not.
Thank you very much for that. And before I gave Mike back to him so that he can wrap up that explanation, of course, the hype right now is digital twin, and probably you can tell why, because of metaverse. I like that mic to be passed to someone who is actually a preacher, an evangelist, a speaker, who is a Zabo Beron, so that I know you are out, but someone here is saying that AI and ML, it's just a hype. Nothing much about it, nothing fancy about it. Yeah. Make a case.
AI is not a hype. Actually, we've been practicing AI manually for long. If you have been in statistics, economics, most of the major policy decisions have been analyzed through these mathematical algorithms manually. So we are just translating this traditional mathematics we have been using in all sectors into software-based. We have been using linear algebra for long. That's where neural networks are coming from. Who has never used linear algebra? Statisticians have been using time series for long, but manually. Now we are just automating the whole process. We are translating mathematics we have been using for long into software. So it's not a hype, and it's here to stay. If you can't change will change you.
Again, guys, I said that is a ramp session, right? That's a ramp session. So let's have the final thoughts from him as he wraps up on that, and then we'll get going because she's already up.
Thank you. Yeah. Thank you. Yeah, I believe it is overhyped, Ezabo. Because the products that are out there that deliver value, it's sort of like it's not tangible. We can't see them. Yep. Sorry, it's not.
Hi, sorry, yeah. So Isabel, I get your point, but I think it is overhyped. In a way, we promise a lot that machine learning can do, but what is tangible on the ground, what is there in the market, is actually not meeting the expectation that we have. But it's a look, eventually we will get from that. We've come from maybe we are hyped right now, but we'll get to the disillusionment and then we'll get to the plateau of productivity. Yeah, thank you.
Again, that's a round session. Guys, that's all what we had prepared for you. And as a follow-up to what a round session has actually brought is a question that Jerry asked. Is decrease important? And tomorrow we'll have a session about that in the evening. So Steve will be working around the logistics, so it's an option. So if you won't make it, it's fine. But before dinner, we'll start with that so that we can crack our brains and again have that kind of an engagement. Thank you very much, and a round of applause to our guests as they sit down.
Working with Kitinji, that's what you always expect. It's going to be interesting, it's going to be interactive, and it's going to be memorable. So another round. That was a pre-session of what we're going to have next. So we have, like I said, we are building innovation, technopreneurship, that one. So we're building that, and we have ramped you up for that. So now we're going to have pitching sessions from our very own students. We have teams from more universities. Let me not say names. You will come and introduce yourselves, introduce your team. So if you are part of the team doing the pitching, please make your way to around here and here. We have our judges as well. So to our judges, please come to the front. Also, if you want to get a closer look to the project, you can always come in front again. Also, to the guys at the back.